Just imagine you wake up tomorrow morning and civilization's collapsed and disappeared, and you have to ask yourself, what do I actually know how to make or do? How could I go about rebooting civilization? For many good reasons, we would have to reboot civilization after some kind of global catastrophe, after some kind of doomsday event or apocalypse, along a different trajectory, along different developmental lines than we did first time round in our own history. What would you most want to whisper in someone's ear, like 2,000 years ago, or if someone's having to go through this process again, that once you've told someone, it kind of makes immediate sense? If you just tell someone the most useful thing to do or to try, you don't have to stumble across that invention again serendipitously, like we did in our own history. You can leapfrog straight to it, cut out hundreds of years of fumbling around in the dark. If you took the risk of catastrophic civilization collapse seriously, and I think there's good reasons to take that seriously, there are pragmatic, hands-on things we could be doing about that right now to dramatically increase the chance of a rapid bounce back, of a rapid reboot.
Hey listeners, Luisa here. You were just listening to Louis Dartnell, who Rob and I interviewed back in 2022 about his book, The Knowledge, which is a really deep dive into a thought experiment about how humanity might fare if the unthinkable happened and civilization collapsed. Today, we've got another compilation for you of our favorite bits from past shows. This one, some of you might know, I've done a bit of research on myself. It was actually my first appearance on the podcast. I was a guest and I talked to Rob about why global catastrophes seem unlikely to kill us all. So, pretty lighthearted stuff. But I actually think you'll be pleasantly surprised by how this episode is not only fun and fascinating from a scientific and sociological perspective, but also filled with many hopeful messages about human ingenuity and practical solutions to seemingly impossible challenges. Of course, it's also dark, dark stuff to reckon with, so maybe keep that in mind when deciding whether to keep listening. In the episode, you'll hear from me, plus 12 other guests who take us through a range of civilization-threatening scenarios and exactly what we'd need to do to make ourselves more resilient if the worst should happen, like Zach Weinersmith on why we shouldn't bet on space settlement to save us from problems on Earth, Toby Ord on the many risks to our atmosphere from supervolcanoes, asteroids, nuclear winter, and extreme climate change, David Denkenberger on his team's work to ensure we have resilient food systems in place to prevent widespread panic and famine, Louis Dartnell on how we could rediscover essential information in the aftermath of collapse, Kevin Esvelt on the scariest pandemic scenarios that could quietly and quickly bring down civilization, Andy Weber on what people in the Pentagon think about nuclear winter, plus loads more. All right, I hope you enjoy.
Zach Weinersmith on how settling space won't help with threats to civilization anytime soon, unless AI gets crazy good.
There are some arguments for settling space that I think you don't think are very good. So one is space will save humanity from near-term calamity by providing a new home. Why do you think that is a bad argument?
Yes, yeah. I'm excited to talk to y'all about this one because it's in your wheelhouse.
Exactly.
Yeah. So we're talking about X risk, right? So imagine you have the ability to shift funds around however you like to try to make it through the next century. The question then is space settlement on your docket? Or what's your allocation? And I would say it's probably zero. Because, so pick your calamity, right? So if your calamity is some sort of worldwide disaster like nuclear war or an asteroid, you calculate the amount of people you need to have a permanent Mars settlement is going to be enormous. It's probably on the order of 1 million people, maybe multiple orders of magnitude larger to have a settlement that could survive the death of Earth or the loss of contact, let's say. If you're talking about climate calamity, massive global warming and like the southern hemisphere is just uninhabitable. The thing to know is that Mars is still 1,000,000 times worse. Maybe we'll get to this, but just Mars is like worse than a Superfund site. It's a disaster. It's worse than trying to live in Antarctica. And so unless that climate change is like even beyond a worst case IPCC scenario, it's still a bad idea. And even then, like if the goal was just to have a human pocket that survives, you should dig a hole or put a city underwater. It's going to be much easier than doing Mars. So I don't think the X-risk stuff applies.
So if kind of progress continues as it's been, or maybe like speeds up at the rate that you'd expect it to based on historical trends, we shouldn't actually expect to have, I don't know, 1 million people on Mars anytime in the next decades, maybe much longer.
Yeah.
One reason I wonder if it might happen faster than that is if AI becomes as smart or smarter than humans and is therefore able to accelerate progress on some of these technological challenges. So right now, there are companies spending enormous amounts of compute trying to train really smart AI systems. But at some point, if they become really, really smart and we have like trained systems that can do a bunch of science, which I think is the goal of many or some of these companies, and then we can kind of redirect that compute to running many, many, many of these systems, potentially millions of systems. And if we threw just like, I don't know, even a tiny fraction of that at space settlement as a scientific and I guess social problem, you might think not all, but some of these problems might get solved, I don't know, on much shorter timescales. There's still the problem of like, well, some of these things just, you can only get data on them at kind of like biological timescales. Humans need as much time as they need to develop as they need. Trees need as much time to grow as they need. But still, you might think that we can accelerate a lot of it, and AI might help us kind of optimize these experiments for the right, or to get like the kinds of data we need in the most efficient way. Does that sound at all plausible to you?
Yeah, so I'm like excited about this AI stuff. I think we have to be, it's tough because on the one hand you want to, as we try to in this book, we stick as closely to what's known. We don't like to do a lot of speculating, but you're right. If the truth is everything's going to change completely in 20 years, that would suggest that some of the stuff we say is wrong. So a couple thoughts. So one is, you can imagine a world where, for example, we have like in silico drug development, and actually it turns out there's a great way to halt bone loss and muscle loss, and hey, it's safe for pregnant women and babies. That would be great. I mean, it's possible. We don't even know if such a drug exists, but it could be, and that would definitely change that aspect of things. Although it's hard to imagine that a future where even if you say in silico this is totally safe for pregnant women, that it's still ethical to do. But I don't know, maybe it's a brave new world. I don't know. So the next thing is, if we're talking about X risk, then I am not sure how much that technological improvement reduces it. So for example, people will often say to me, well, what if, there's some really cool fusion stuff going on right now. It's these neat new like superconducting tapes and things. And AI is helping with plasma confinement. So, hey, maybe in 10 years, we can send a plasma rocket to space and it'll be able to either, bring a lot more mass or get there a lot faster, or maybe both. And is that going to change your equation? And absolutely. But on the other hand, one of the things we haven't talked about yet is that one way you're increasing existential risk is just by putting massive amounts of big, heavy stuff in space operated by many players. So the math I like to give on that is just if you have an object moving at 3 kilometers per second, when it impacts, has an explosive yield equivalent to it being made entirely of TNT. Objects in low Earth orbit go more than twice as fast, and the yield is the velocity squared. It scales with the square of the velocity.
Whoa,
so if you imagine a world where like every country has access to millions of tons of space objects, many corporations do, individual rich people do, that's just a world of enhanced existential risk. And I don't know that there's a way to avoid that unless you also want to postulate like tractor beams and weird, really spacey stuff, And so, if you strap a plasma rocket to that, it gets there faster, but you haven't obviously reduced your danger. Mm-hmm. So just in terms of, at least if the question is colonizing another planet to reduce existential risk, it's not obvious to me that adding sci-fi elements, even if they're real, makes you safer. The last thing I want to say is, when we look at numbers, we try to look at numbers of how many humans you need for one of these operations, and there's a lot of debate. There's questions like genetic and breeding stuff, but the bigger question is, can you go economically independent? The lowest number we found was from a kind of, I would say, very optimistic analysis done by Dr. Casey Hanmer. And the bounds he came up with, which assumed big advances in AI robotics, I think the lowest number he was willing to do was 100,000 humans to have a permanent settlement. So what I, my response to that is, one, at least short term, there's no way, depending on what short term means. But I would also say, to me, if you're saying we can do Mars just as soon as every person has the equivalent of 100 robot butlers, we're talking about Mars not as a kind of destiny thing, not as a frontier thing, not as a human enhancement thing. We're talking about it as the aesthetic choice of an advanced humanity, right?
Right.
It's Star Trek. And so to me, that's the deep answer here is yes. I mean, we worried about the existential risk aspect, but say it this way: for me, if I'm in a world where we all get 100 butlers, I'm probably staying home. I'm glad there are people who are ready to go Mars. I will be walking my orchard, being fanned and fed cupcakes. And the last point I want to make, and this ties to the X-risk thing, if you want that sounds very tempting to you, and it does to me, then you need to make sure humanity makes it through the next century. Or the next 20, 30 years. And as we agreed earlier, if your goal is to reduce existential risk, it's really not obvious that space is the way to go. So you're absolutely right. And I'm I want to absolutely admit, AI has gotten so weird in the last few years. I don't feel like I have any kind of prediction capacity for what 5 years looks like, at least in terms of, LLMs and stuff. But at least if we sort of say, if you have it for Mars, you have it back on Earth, I think it at least changes the nature of the question.
Luisa Rodriguez and what the world might look like after a global catastrophe.
So the big thing we're here to talk about is this series of articles you've written on the probability of humanity ultimately recovering and building back from a serious collapse of civilization. I guess, not many people have, as far as I know, kind of considered that in a sober way. It seems like an area where there's a lot of loose talk and maybe not a lot of hard talk. Yeah, how did you first get into this topic?
Yeah, exactly. I got into the topic because after thinking about nuclear war, where I'd done this big project thinking about whether a nuclear war would cause a nuclear winter and whether a nuclear winter could cause human extinction. And I ended up feeling like it causing human extinction was pretty impossible. It's just really hard to tell a story of how that actually happens. Yeah, I guess it still seemed bad to me if nuclear winter caused civilizational collapse. But then even when I reflected on that, collapse isn't necessarily as bad as human extinction, at least on its face. And then I realized I actually just had no idea if it was as bad as human extinction. I didn't know if it would necessarily lead to it. I didn't know if it was completely implausible that it would lead to it. And then it just started to feel like this gaping hole in a lot of these global catastrophic risks that get you part of the way to extinction. Lots of people die and it's horrible. But I couldn't find any really plausible stories, at least right away, for thinking that it was as bad.
What sort of different disasters did you analyze?
Yeah, so I found that it did kind of matter the type of disaster that you're talking about to how likely it is that civilization would even collapse, but then also to how likely it is that civilization would recover from collapse. So I tried to take a few examples, just to keep the scope narrow enough to even think about, that got at some of the key parameters or something of a catastrophe.
Yeah.
And I didn't quite hit all of the ones I wanted. But the main three I considered were a scenario where 50% of the population dies. Like you can imagine it as a pandemic. So you have high population loss, not extremely high, but much higher than, for example, COVID, but then no loss of
physical infrastructure. The houses are still here.
Yeah. And aside from the fact that basically the climate is the same and there are kind of no lasting environmental effects too. So that's kind of one case where you're just toggling up and down on population death. Another that I thought about was adding in infrastructure damage. And because nuclear war seems like kind of a plausible catastrophic risk, I went ahead and just tried to think about nuclear winter in particular. So for that one, I thought the parameters would be something like maybe 90% population death through both kind of the initial war and then famine in the very immediate aftermath of the nuclear winter. And then I also thought there would be something like 5 to 10 years of environmental effects, but then those would go away. So that was another one. And then the last one I thought about was I was trying to come up with basically a set of catastrophes that might make the story look worse. And yeah, for the thing that I've actually written up and posted, I ended up thinking about nuclear war and biological weapons. And so in that scenario, I ended up assuming that population death would be much higher, so 99.99%, which I think leaves you with 800,000.
Okay, so 800,000 people left globally. Yeah.
Yep. And then I also, you still had the infrastructure damage and you still had the environmental effects that were temporary. And so that was one of the worst cases I could think of. And then one that I've kind of thought about since writing publicly about the topic, so maybe a fourth one, is what happens if you have a nuclear war that kills lots of people, but then you also have climate change or like climate effects that do last for a really, really long time, on the order of like not a decade, but thousands of years.
Yeah.
So yeah, those are the kind of main like parameters I see being important. Ended up being how many people die, whether like stuff is left standing, so infrastructure is standing, whether there are environmental effects and how long all of these effects kind of last. So kind of regardless of the scenario, a thing that kept coming up as important was the fact that catastrophes will kind of inevitably be non-uniform in their effects. So I guess if you have a catastrophe that's so big that it's actually uniform in its effects and it's really severe, it's going to kill everyone. So that would be like a catastrophe like an asteroid that actually really impacted the Earth, or maybe actually like...
It's like even bigger than the one that killed the dinosaurs or something like that.
Yeah. So that is one where you can imagine having consistent mortality rates everywhere, consistent climate effects everywhere. But for the catastrophes that interest us, so the ones that don't actually kill everyone at once, but leave some survivors, the reason that happens is because the catastrophe is going to have non-uniform effects. And I think for lots of catastrophes, they could just be very non-uniform, where like you might get some entire continents that are much, much less affected than others, both in terms of population death and in terms of climate effects. So an example, a nuclear winter that's kind of well known is you have some continents where agriculture becomes near impossible, and then you have others where it's like maybe even a bit better.
Because it's colder, or?
Because it's colder and otherwise was too hot for agriculture.
I see. Before,
yeah. And that's like probably mostly you wouldn't get better. You just get...
it wouldn't be quite as devastating
as
elsewhere.
It would still, be possible.
But I guess, so this non-uniformity is super central if you're thinking about, will it kill 100% of people? Because it's, even if there's just like 1% of people living in some place that's largely unaffected, then that basically answers the question for you.
Exactly. And I think sometimes it's slight non-uniformity that makes a bit of difference, maybe isn't decisive. So like with nuclear winter, you'll have some areas that are cold and some areas that are slightly less cold. But some, I think, catastrophes would cause extremely non-uniform effects where like even if you had really, really enormous population losses and kind of actually the collapse of society and political systems and all of these systems that we think of as critical collapsed on one continent, I think you might see society continue on others. And I think that's something that I didn't intuitively have in my head when I first started thinking about this, is just some places might really be kind of unfazed.
Right. Thinking about New Zealand again, because I guess just I suppose there's also Tasmania. Are there any other things that we should have in mind? I guess it's like Pacific Islands.
Pacific Islands. Yeah, I think depending on the thing again, in some scenarios, you really want coastlines because fishing is like a key source of food. So like Chile looks kind of good in a couple of scenarios. I think those are the main ones. I think it's just like the really interesting emergent finding is like number of survivors really does interact in a kind of funny way with other things. So supplies left is a good example where if you have lots of survivors, the supplies go very quickly. But then on the other hand, if you have lots of people dying, which would be terrible in some respects and makes it a bit harder to rebuild industry and harder to make sure that you well, ideally that you'd keep some of the necessary knowledge and skills you'd want to at least eventually rebuild industry. When you are down to tens of thousands or hundreds of thousands of people, it's like less guaranteed that you'll keep all of those skills. And so you just get these kind of trade-offs. And I think mostly I felt like it worked in favor of survival.
Okay, so this kind of relates to this concept that you have called the grace period. This temporary time after some disaster where a bunch of people are now dead, but I guess you had this overhang of supplies from the pre-apocalypse world, and I guess other things like cars are around, like other infrastructure. So this like potentially helps you to stick around and then rebuild. Yeah, do you want to elaborate on that?
Yeah, sure. Yeah. So again, it's kind of depends on the catastrophe, but at least in some places, in most catastrophe scenarios, you have maybe all of the infrastructure that you did otherwise. You have a power grid that still exists, even if it's not working. You have grocery stores with food in them. You even have petrol stations that still have petrol in them and that you can siphon out pretty easily. So you have things that mean that you can kind of survive in a reasonably easy and accessible way. And just how long that period lasts, again, depends on how many people there are. But I think you'd be kind of surprised how much stuff you can still access, with the limitations being like the power grid will stop working, but like even water will still run for at least a while, and even maybe for a long while in some places where the water supply isn't run by electricity and
gravity.
Yeah, exactly.
Yeah. Is it a way of like giving a sense of like how long it is, or like what kind of stuff might we run out of first?
So if you have 50% population loss, I think that theoretically, if you actually allocated all of the food and water, kind of literally rationed it, then it would only last days, like under a week. If you actually just divide like the US, China, some of the really big food suppliers, like over everyone.
Yeah.
We used to have many more, or like a much greater volume of food stocks than we do now, especially during the Cold War, kind of unsurprisingly. But currently, lots of countries have about 6 months of grain reserves, and then lots have basically none.
Okay. But I guess, so that means that then if you have a situation where 99% of people suddenly die, then now you can last years with that kind of food.
Yeah. So it's years if you make a few assumptions about how you prioritize the ordering, basically, in which you eat things.
David Denkenberger and the catastrophes that could cause global starvation.
There are a number of catastrophes that could disrupt agriculture globally, and the most extreme ones could basically collapse agriculture. These are ones that could block the sun. So they include a large asteroid, like that caused the extinction of the dinosaurs, a supervolcanic eruption, like almost many people think caused the extinction of humans about 70,000 years ago, and a nuclear winter. And this would be caused by what's called full-scale nuclear war, involving thousands of nuclear weapons between the US and Russia. And this causes burning of cities, and smoke goes into the atmosphere, and it can remain there for a decade. And so in these scenarios, since almost all of our food comes from plants that need the sun to grow, it's generally assumed that most people would die. We only have a few months of food storage, and people who have looked at this problem before have suggested, well, let's just store up more food. And that would be technically possible, but as a way of visualizing it, you can think of a 120-liter or 40-gallon oil drum. If that's full of dry food, that can feed a person for a year. But to have enough food to feed 7 billion people for 5 years, you would need to pile those drums from the Earth to the moon and back 40 times. So as you can imagine, that would be very expensive, many trillions of dollars, and you can't do it really fast. It would take a while to store up that food, but you would want to do it as fast as practical so that you're ready to weather disasters that could happen at any time. But if you store it up fast, then you inflate the food price, and then millions of people more would die of malnutrition than already occurs. I wasn't satisfied with that not very good solution, so I was thinking, well, is there another way of producing food when the sun is blocked. And 2011, I was reading this paper called Fungi and Sustainability. And the premise was that after the dinosaur killing asteroid, there would not have been sunlight and there were lots of dead trees. And so mushrooms could grow really well. But its conclusion was that maybe when humans go extinct, the world will be ruled by mushrooms again. But I thought, why don't we just eat the mushrooms and not go extinct? And so then I branched out from mushrooms, thinking of all the ways that we could convert either dead vegetation into food or even fossil fuels into food.
Yeah, so I just love this idea, whether it's practical or not. I'm just so fond of it because you've taken kind of a problem that most people have just thought of as inevitable and basically accepted that if there's a nuclear war, then maybe billions of people will die of starvation. And I guess bringing an engineering mindset that you've been trained in, you've just seen this as a practical challenge to overcome and pretty quickly come up with a bunch of seemingly plausible ways that we could actually just feed everyone, even if the sun were completely blocked out, which is amazing.
Yeah, that's right. And I do think that engineering mindset is really important in that, certainly it's important to know what the problems are and ideally prevent them, but realistically, they still could happen. And so I think that there should be more work done on this resilience end of the spectrum.
Who's working on this problem? I guess there's some people who try to stockpile food, and presumably some countries have food stored away. Yeah, how much is there, and what else are people trying to do?
Well, there are certain countries that have done a lot of food stockpiling. One of them is Switzerland. I believe they have around a 1-year food supply. I think China does as well, though it's not public knowledge. So you don't know exactly. But on average, it's more like a few months across the world. And you'll often hear numbers of, we have 2 months of grain supply. That's actually about right, but for the wrong reasons. So it's at current grain consumption. But of course, we feed half of our grain to animals. So if we did have one of these catastrophes, hopefully we would be not feeding as much edible food to animals. So that helps. But there's also the fact that most of our stored food is grain because it's really easy to store dried. And half of our calories comes from food that is not grain. And so we have less food storage that is not grain. So it works out to just a few months of food storage. And it depends on what time of the year, but that's the minimum.
Let's just dive into thinking about the nature of the problem that you're solving and the concrete solutions that you've come up with for it. So not all listeners, I imagine, will be convinced that kind of a mass starvation of humanity is a terribly likely risk. So let's go through what are the major possible causes of a global food shortage and how likely might they be?
So I mentioned asteroid and supervolcano, but as the existential risk community has pointed out, generally the natural catastrophes can't be that bad because they can't be happening every century or we would have been doomed long ago, though, of course, there is the possibility that we've been extremely lucky, which people have tried to adjust for. But I think still, even adjusting for that, the natural catastrophes are lower probability.
Do we have any estimate of the probability of an asteroid or supervolcano that would cause a risk to human food supply?
Yeah, if you're talking about blocking the sun, then it really is around 1 in, I think, 10 million years. Or 100 million years for an asteroid. And the volcano is more likely, more like 1 in 100,000 or a million years.
How robust are those estimates? Because I know we've had a couple of volcanoes erupt and change the biosphere during the million years or so that humanity has been around.
Yes. The latest estimate I saw on the supervolcanoes was actually coming up with a larger number, that they happen more frequently. Apparently, it's difficult to identify further back than a few million years. So there's some uncertainty there. There's also uncertainty whether the supervolcanic eruption would actually block the sun well enough and long enough to cause mass starvation. And so it's the same with nuclear war as well. And I've written a paper that tries to go through all the uncertainties of, well, how many nuclear weapons would be detonated, which cities would be hit, what fraction of the combustible material actually burns quickly, how much of that turns into smoke, how much of that smoke makes it into the upper atmosphere, and how much do the particles block the sun, and then how much does it impact agriculture. And as you can imagine, there's uncertainty in all of those steps, so it adds up.
What about the more moderate cases where, say, there's a more normal war or only a regional nuclear war? How much would that interfere with the food supply?
So that's the class of catastrophes that I've been labeling the order of magnitude 10% global food production shortfall. So roughly like 33% loss to 30% loss. And in those scenarios, there are a number of catastrophes that could cause that. As you mentioned, regional nuclear war, like between India and Pakistan, that might only involve 100 total nuclear weapons, and actually much smaller nuclear weapons than the US and Russia have. But still, they would be targeted at highly populated cities. And so some work on this has estimated something like a 10 or 20% global food production shortfall because of it. Then you can think of smaller versions of the natural catastrophes like asteroid and supervolcano, but again, they're not too likely. But another one that's received some interest recently is called the coincident extreme weather, or multiple breadbasket failure. So here the scenario is you have droughts or floods on multiple continents at once. There was a UK government study on this that estimated right now it might be around 1% chance per year, but with the slow climate change, that extreme weather probability, so difference between climate and weather, actually gets more likely. And so they were getting more like 80% chance this century that something like that would happen.
Wow, okay.
And then there are other scenarios as well, like the super weed, which is not the savior of medicinal marijuana users, but is instead a weed that outcompetes crops. Now, if this were a natural thing, we could probably contain it or at least slow it down so that it wouldn't happen too fast. And if we have more time in any of these, it makes it less extreme. But it could be an actual coordinated terrorist attack. And there have been some examples of people trying to use, I think that was more a crop disease, but that's another category, something that would kill crops directly. Could be a coordinated attack as well.
So a super weed sounds a bit outlandish because how would a weed spread all around the world really quickly? It seems like wouldn't a super pathogen like a virus or a bacteria be more able to spread to lots of crops quickly enough that it's hard to respond?
Yeah, right. It's hard to have something that can live in many different climates. Yeah, I'm particularly worried about on the crop disease. If something could target the grass family, then you affect not just grass that feeds a lot of our animals, but also wheat, corn, maize, rice, and sugarcane. So if you add up all of the human calories, it's something like 2/3 of our calories comes from the grass family. So that really could be catastrophic.
You mentioned in the book that a coordinated terrorist attack using superweeds to destroy a lot of crops across a really large region could be a global threat that not that many people are thinking about. Do you have any evidence that a group might actually plan such an attack or has been considering planning such an attack? And do you know if anyone else is working on trying to figure out if this is a real risk and what might be done?
I have not heard of evidence for this particular type of risk, though a related one is crop diseases, and these have been used in biological warfare programs. So there is concern that this could be a potentially larger attack. As for the probabilities, I haven't seen anything quantitative, and so I just try to quantify what I can and then say, well, we're not including all these other things, so really the risk is higher.
Are there any just non-nuclear wars that you think would create the scenario that are plausible? I mean, yeah, who could end up fighting without nuclear weapons? And it would, I mean, if you had a major war, wouldn't that massively interfere with trade? And so some countries that are currently importing most of their food could well end up starving pretty fast.
That's right. And the other scenario that could really interfere with trade is a pandemic. If it were a severe one, then it may be rational to close borders to reduce transmission. But you're right, importing food countries would be in big trouble. Or it could be a smaller pandemic and it just people overreact. So it might not be rational, but they still might close the borders. There are a couple other scenarios that could do similar to this idea of a 10% global shortfall.
Yeah.
One of them is called abrupt climate change. So this is like Europe going back into the ice age, which some people have talked about because of breakdown of the thermal haline circulation of the ocean that's driven by salt. That could be a 10% shortfall. And another one that people have talked about and some existential risk researchers are looking at is extreme climate change. So it's global, but it still happens slowly, like over a century. And that's a little different than the problems I'm mainly focusing on, but I think some of the ideas could be relevant to that.
Louis Dartnell on how we could rediscover essential information if the worst happened.
We've got this big common interest in understanding how humanity would recover from a major catastrophe that knocked us back a long way. Yeah, collecting a bunch of information that would be useful for survivors to a disaster was the topic of your book, The Knowledge, How to Rebuild Civilization in the Aftermath of a Cataclysm. I guess, yeah, to get straight to the most important issues here, what's one thing you think humanity would find especially difficult about recovering?
Do you know something that I don't know?
Yeah, sorry, knock wood. Yeah. Would find especially difficult about recovering to our level of technology, say after a pandemic that killed 90% of the population or something around that level.
Let's just imagine you wake up tomorrow morning, and civilization's collapsed and disappeared, and you have to ask yourself, what do I actually know how to make or do? How could I go about rebooting civilization in the way you reboot a computer after it's crashed? And as you're asking about, for many good reasons, we would have to reboot civilization after some kind of global catastrophe, after some kind of doomsday event or apocalypse, along a different trajectory, along different developmental lines than we did first time round in our own history. What I tried to get at in the book and The Knowledge was using this thought experiment, using this playful hypothesis, this scenario of the post-apocalyptic world, to answer as a genuine question, but by doing so looking into our own history and how we got to where we are today and why the world looks the way it does. One of the ideas I played with in The Knowledge was, what would you most want to whisper in someone's ear, like 2,000 years ago, or if someone's having to go through this process again, that once you've told someone, it kind of makes immediate sense, or you give them a very simple set of instructions for how they can make something or build something or demonstrate something for themselves. And for me, the one that stood out by far the most significantly was this idea of germ theory and how that links to the microscope. That imagine that the centuries and centuries and centuries of human suffering through history because we didn't have the right idea about why people got sick and why they died and why plague seemed to spread very quickly through cities and from person to person. So if you told people that the reason people get sick isn't because of bad air, malaria from the Italian, it's not because of some fractious god has smited you, it's because there are things which are invisibly small. They're so small, so tiny, you can't see them with your naked eye. But they're there and they get into your body and they multiply and you pass from one to the other. But tell you what, this is how you make glass from scratch. And I give the recipe in the book. And actually one of my favourite maker projects when I was researching for The Knowledge was making some Robinson Crusoe glass from scratch. I went to a beach and I got sand and seashells or chalk and soda ash, sodium carbonate, and made some glass from scratch in the course of a weekend, which you could then fashion into a lens to manipulate and control light, and then build a microscope from it. And there's nothing stopping the ancient Romans over 2,000 years ago building a microscope if only they'd known what to do. If you just tell someone the most useful thing to do or to try, you don't have to stumble across that invention again serendipitously, like we did in our own history. You can leapfrog straight to it, cut out hundreds of years of fumbling around in the dark. And perhaps the best way of doing that would be to build these repositories of human knowledge, something like a manual for civilization or a total book, a book that contains the sum total of human knowledge, but also organized in a way that is useful, in a sort of progressive, holding your hand and leading through the steps of the ladder, unlike something like Wikipedia, which is an absolute mess of information just dumped in there. And you might then have these repositories of the sum total of human knowledge dotted around the globe, and maybe have some big conspicuous markers that point your post-apocalyptic survivors to where their local library for rebooting is. And I appreciate this starting to sound a lot like sci-fi, and this sort of idea has been explored really well in some cracking books. But yeah, I think it is an intriguing idea. It is something that if you took the risk of catastrophic civilization collapse seriously, and I think there's good reasons to take that seriously, there are pragmatic, hands-on things we could be doing about that right now to dramatically increase the chance of a rapid bounce back, of a rapid reboot.
Andy Weber on how people in U.S. defense circles think about nuclear winter.
I've had this kind of long-standing confusion about the issue of nuclear winter. My impression is that there's some natural scientists who come at this question from kind of far outside the national security community who think that that's a real threat and a real likelihood. Though admittedly, it seems like it's a pretty small community of people who study climate and study physics and so on who have looked into it in any great detail. But I get the sense that there's this more skepticism or just kind of disinterest maybe from people who are approaching this from the national security or nuclear weapons point of view, that it's not talked about that much. And relative to the stakes that seem to be on the table there, where it's a question: if we use nuclear weapons, would it like lead to billions more people dying because of this nuclear winter? It would seem like it would be a really high priority, but doesn't get a lot of take up as far as I can tell from the Pentagon. Yeah, to what extent do people in US defense circles take nuclear winter seriously, and do they think about it at all?
We do, and we do take it seriously. But you're right, there has not been as much investment in recent years in the types of research that led to the conclusions in the 1980s regarding nuclear winter. And our modeling capabilities have gotten so much better. So we should invest again in those types of studies. But there is no question that a massive use of nuclear weapons would cause a nuclear winter.
As I understand it, kind of the crux of the disagreement is how long it would last, which kind of comes down to how high the particulates from the burning cities and forests go. Because if they go high enough, then they tend to just stay up in the upper atmosphere for a very long time. But if they're in the lower atmosphere, then they kind of rain out and fall down. Have I got that right?
All of that can be modeled. And the conclusions of the work that was done previously have not changed. So this is a real concern, and this is just one of many reasons. I mean, let's talk about the lives.
If we needed more.
The lives, right? And let's talk about the lives that would be lost with the use of any nuclear weapon. People who would be killed immediately. So we need to make sure that nuclear weapons are never ever used.
Yeah. So you think there's kind of not that much dispute that, so obviously it would have like a large effect on the weather, but you think we're talking like many years and a lot of people starving, that is the most likely outcome of a major nuclear exchange?
Oh, absolutely. Absolutely. It would be a near species ending event.
And do other people do other people who've worked in the Pentagon or people who think about nuclear policy, is that their view as well?
I think it's generally accepted, yes. It's not something we dwell on or talk about very much. And like I said, there has not been much work funded in this area in recent years. But I think it's general conventional wisdom that a large exchange of nuclear weapons would cause a nuclear winter.
Okay, yeah, well, I guess, it's good to know that, that people believe that. That seems better to maybe err on the side of caution with that one.
Toby Ord on risks to our atmosphere and whether climate change could really threaten civilization.
So the mechanism from supervolcanoes and from asteroids and from nuclear war, the main mechanism for causing existential risk is via a kind of nuclear winter or volcanic winter or asteroid winter, where particles get up into the stratosphere so high they can't be rained out, and then they cause global cooling. Cooling, darkening, and drying, but the cooling's the main one because it shortens the growing season for crops. So that's the main concern. And interestingly, for all three cases, it is a form of climate change, and it is, mediated by atmospheric science, is the kind of subject that studies this. So if you look at the size of these asteroids, 10 kilometers is very big. It's the size of a mountain, but it's very small compared to the Earth. And the kind of image you might have in your mind of the asteroid kind of plowing into the Earth, it is more of a pinprick than, two things of similar size.
It's so much dust.
But it is the dust. So, I guess these type of people who, which would make them a climate denier, that, they could deny that there would be these dust effects and things. And in the case of nuclear winter, there was a lot of denying of this. There was a lot of pushback that Carl Sagan and others received on the theory, partly because it was a politicized issue, somewhat like, we're seeing with climate change. So one could push back on supervolcanoes and asteroids for this same reason, but you don't see that so much because it's not politicized.
Yeah.
It's interesting that so many different risks share this same mechanism. It suggests that one of our biggest vulnerabilities is our atmosphere or is our access to sunlight.
Yeah, that's right. And there's a useful way of thinking about this, which is that once there's some kind of event, is the event so big that it just would obviously destroy the Earth? You know, for example, if an entire planet crashed into the Earth or something, where it would be pretty obvious how it gets big enough. But in other cases, there's this question about how does it scale up to be something that could threaten us all? How does it get everywhere, like to all the humans and so on? In the case of all of these things, what happens is that the atmosphere is what takes 1,000 kilometers of rock, or square cubic kilometers of rock, or what have you, and distributes it in such a way to create this opaque layer around the Earth. And without the atmosphere doing that, it would be more of a regional catastrophe. And then the atmosphere is also important in climate change. And also temperature changes are also important there, and the effects of temperature change potentially on crops. So there's actually, quite similar things about some of these natural catastrophes and even some anthropogenic ones that are quite interesting.
Did your opinions change at all, I guess, on how resilient we would be to these changes? Because I suppose at the moment it seems like kind of human ingenuity is winning out. Like the climate's heating, but we're getting so much better at farming all the time that, the amount of food output just keeps rising at a pretty good clip. So is it possible that we will just be able to adapt to this because it's happening over decades?
I think so. It would still be much worse than if it wasn't happening. So just to be clear on that for the audience, that
we're talking here about like, would we all die? Would it cause the collapse of civilization, which is a high bar?
That's right. It's an extremely high bar. And while there are a lot of things which could very clearly cause a very large amount of human misery and damage, it's quite unclear how it could cause the extinction of humanity or some kind of irrevocable collapse of civilization. I mean, I just don't know of any effect that could plausibly cause that. There has been some analysis of if you had very large amounts of warming, such as 10 degrees of warming, would it start to make areas of the world uninhabitable? And it looks like the answer is yes, at least being outside. Air conditioning could still work. It'd still be much more habitable, say, than Mars, where people are perhaps thinking of setting up, settlements. But also, that argument, though, really, if you run it through, it really just suggests that the habitable part of the world would be smaller. So coastal areas are much less affected. High plateaus, such as Tibet, wouldn't be kind of moved to super hot temperatures. So there would still be many places one could be. It would be a smaller world. And it seems hard for me to think, given that it wouldn't be that much smaller, as to why then civilization would be impossible or a flourishing future would be impossible in such a world. That just doesn't seem to have much to back it up at all.
So even if it was a third of the size, then one might think.
I mean, if we heard that someone had found a planet in the habitable zone around a nearby star, and that but it had a lot of ocean and only had a third of the landmass of the Earth, we wouldn't think, oh, well, I guess no need to worry about ever meeting anyone from that planet because it's impossible to create a civilization on such a planet. Or if, say, it was only the Americas and you didn't have Africa or Eurasia or Australia, that, obviously, you never could have had civilization there or you could never sustain it. That would seem kind of like a pretty crazy view. So I don't really buy the idea that large enough parts of the Earth could be made uninhabitable either.
Well, at degrees of warming like 10 or whatever, but if we get up really high, I mean, it seems like it's not totally
I looked at these models up to about 20 degrees of warming, and it still seemed like there would be substantial habitable areas. But it's something where, it'd be very bad, just, to be clear to the audience.
Most people are dying.
It'd be very bad.
Yeah.
But it's hard to see any particular mechanism that's been floated as to how it would happen on model. But my concern is more that just the prior probability, before you even got into these models or kind of got into the science of it, if we make, an unprecedented change to the Earth's climate, perhaps at a truly unprecedented rate over the last 4 billion years, and also to a level which is like only a couple of times been reached or something, and never been reached with the current configuration of continents or with the species like us and so on, that it does seem like there's just, some plausible chance that this is the end. It's not that if you imagine kind of appearing before St. Peter at the pearly gates and he said like, hey, so it was climate change. And you could say, how could we have possibly known that that making these radical changes to the Earth climate that hadn't been seen for millions of years could do us in? I think we'd be looking pretty foolish if it does seem like even if we said, but we haven't, our scientists, we've kind of looked at these different 5 pathways and none of them could lead to it. And you'd think, well, there could have been one that you hadn't thought of, couldn't there? I mean, in the case of nuclear war, for example, nuclear winter hadn't been thought of until 1982 and 83. And so that's a case where we had nuclear weapons from 1945. And there was a lot of conversation about how they could cause the end of the world, perhaps. But they hadn't stumbled upon a mechanism that actually really was one that really could pose a threat. But I don't think it was misguided to think that perhaps it could cause the end of humanity at those early times, even when they hadn't stumbled across the correct mechanism yet.
Because it was just an unprecedented event.
Yeah, and there hadn't been that many people searching for such mechanisms. They ended up kind of getting there from thinking about other planets. Planetary exploration made people think about how very different atmospheres worked, and to get some kind of data on what it's like to have like radically different atmospheres or dust storms throughout the whole of Martian atmosphere and things like that. And that made them think about this. But, you could easily imagine them just never having noticed that mechanism, actually, since the Cold War ended shortly after that. And so I think that this is just the kind of thing that on priors, it's such a big change. But I want to stress that my best guess number for the chance of the existential risk due to climate change is about 1 in 1,000 over the century. And that's mainly coming from this kind of, I don't know the mechanism, but that our models aren't sufficiently good.
Some real X factor.
Yeah.
Yeah.
I think that it's often suggested that climate change might not be so much an existential risk, but that it's something that would increase other existential risks. So in this case, my terminology would be a risk factor. I think that this is probably right. I think that if we imagine a world, if we could just somehow have the next century, but make it so that climate change wasn't an issue, all of the dedicated altruists who are working on fighting climate change could then work on other things, and the global international tensions on this would go down. And so you could, nations could spend their kind of like altruistic international cooperation kind of budget on something else. So I do think that could actually be quite helpful. As to how big it is as a risk factor, my guess would be somewhere between, say, it's very, very rough kind of guesses, between about 0.1% and 1%. So maybe a bit bigger as a risk factor, but not an order of magnitude, probably not a whole order of magnitude bigger.
So you think it's quite a bit less important than war or great power war, yeah?
My guess is that it is less important from the perspective of existential risk reduction.
It sounded like some of the main mechanisms you were thinking about by which this could be a risk factor is basically that it distracts people. So the budgets of these governments and of organizations and people's personal careers will be spent on it instead of on other things that you think might be more important ultimately?
Yeah, I think distracts is kind of right, but it has the wrong emphasis or something, because I think a distraction can't be that bad. And maybe a better way to think about it is this is a stressor on national and international relations and so forth.
And our capacity to solve problems. It's like now, so our capacity gets used up trying to solve this thing, and then we don't have headspace to think about something else.
Yeah, that's right.
What about if some moderately high level of warming comes about such that there is, maybe this actually just ultimately falls into the bucket of reducing our capacity to solve problems, but it seems like if, health systems and economic systems suffer a lot, it could leave us more vulnerable to things like pandemics, naturally occurring and engineered. Does that seem plausible?
Yeah, I think it's quite plausible that it could leave us more vulnerable to pandemics. Also, the fact that effectively a larger part of the Earth would be in a tropical environment. So I think that this is something that is certainly recognized as that there could be more endemic disease and maybe more pandemics as well.
One thing that what you're saying suggests is that maybe some of the most serious ways in which climate change or something else could be a risk factor is by impacting the other bigger risks. So, even if you think there's a plausible mechanism for it increasing some other existential risk that we can think of, it really matters how big that other existential risk is for how much that translates into being a risk factor.
Yeah. And so I think it may even be the case that, say, the median level of climate change, like the stress that creates on international institutions and governments and so forth, that's large enough to, say, change the risk of, say, the biggest risks, such as AI or engineered pandemics, to increase them by a tenth or something like that, compared to if we definitely could just not have to worry about all of these challenges of climate change. That could be a mechanism whereby it, produces a significant amount of risk as a risk factor. But it'd be interesting to see, some robust conversation about that, rather than, this is just me kind of sketching out some kind of combinations of numbers where I find it a bit hard to see how it would really work. But the people at CSER, the Centre for the Study of Existential Risk in Cambridge in the UK, they are quite concerned about this, and they think that climate change is a much bigger risk, existential risk, than I do. And they think this is largely through risk factors, largely also through things to do with the collapse of civilization. But I think that better characterization of the chance of extreme warming and better understanding about how bad it would be, and could we survive the extreme warming, and, could there really be cases, or blue sky thinking about, we understand a bit about various mechanisms which would cause the kind of central case of damage that we're thinking about when economists model a damage function of warming, and they're thinking about extra disease burden, extra kind of adaptation, crop failure, and so on. But rather to think, are there any things that, like in the case of nuclear winter, some really quite different mechanism which could cause a different kind of threat that only happens when it gets to a very high level? Blue sky thinking about that could be extremely valuable and could then help us much better understand how much of a risk climate change poses.
Mark Lynas on how likely it is that climate change leads to civilizational collapse.
How likely do you think it is that climate change will lead to kind of the breakdown of industrial civilization as we know it today? I guess secondarily, how likely might it be to effectively cause human extinction? And I guess probably those numbers are going to be pretty different. They're two fairly different standards.
Yes. Well, for me, the question isn't quite in the way you framed it. The question is, at what degrees of warming do these outcomes become more likely? And I remember when Extinction Rebellion sort of spokespeople were on the media saying billions are going to die in the next 10 years. And I think it was Andrew Neil actually in the interview said, well, how? What's going to happen? Kill these people? And they weren't able to answer. So it's one thing to have a kind of apocalyptic fear, and another to actually try and think through what the mechanisms are which would actually kill people, if that's what you're concerned about. What kills people? Thirst kills people. War kills people. Hunger kills people. People die because of lack of shelter. So it's different degrees of civilizational collapse. I mean, conflict, war is a civilizational collapse in a way, particularly if it's potentially worldwide. So, for me, I think the most concerning scenario is one where you can't produce enough food to sustain the world's population, which is a lot higher. Remember, by 2050, the latest UN figures are 9.7 billion by 2050. So you have to pretty much double the world's food supply at the same time as you've got less and less of the world's land being able to produce because of the combined impacts of heat and drought. And obviously plants can't grow without water. Also, plants can't grow if it's too hot. I mean, you can push the thermal tolerance threshold of crops with genetic engineering to some extent, but there comes a point where enzymes get denatured and your plant will just die, or certainly, and there's a long time before that yields will fall off and so on. So that's for me the main question. And one of the most important studies I think that's ever been performed on this was a study in PNAS journal, which looked at what they called synchronous collapse in bread baskets around the world. So at the moment, the world still produces enough food every single year, very reliably. We've never had a major food shortage, which has been as a result of harvest failure. So, I mean, if the US Corn Belt was knocked out one year, that would have a huge impact on food prices and have a huge impact on food security, in fact, as a direct result of that. But imagine if it wasn't just the US Corn Belt, it was Australia, it was Brazil and Argentina, it was, bread baskets of Eastern Europe and the former USSR, all of that added together, then you're into a situation which humanity's never experienced before and which looks very much like famine. So that, for me, that's how I answer the question, how are people going to die? People are going to die from starvation if there isn't enough food globally. That's one of the mechanisms. And when that happens, you can actually link with some degree of confidence to levels of climate warming.
So you said you wanted to, the way that you prefer to think about this is in terms of which temperature increases give us a good chance of these kinds of impacts. So do you have a guess at what degree of warming we would need to reach for the sort of full-scale collapse of society, perhaps due to, very, very widespread famine, to have, say, a 10% chance of happening?
Oh, I think you want to put me on the spot. I would say it has a 30 to 40% chance of happening at 3 degrees and a 60% chance of happening at 4 degrees and 90% at 5 degrees and 97% at 6 degrees.
Okay. Now, I appreciate you being willing to put numbers on this because I feel like that's always really hard, but it's really helpful.
And maybe a 10% to 2 degrees. So
okay. So we're getting close to 10% already.
Yeah, but I think these early stages of warming, I mean, we're at 1 degree now, and obviously it hasn't happened, so that's a 0% chance of civilizational collapse unless it starts happening tomorrow. But, the biggest impacts now have been on natural ecosystems. Remember, we lose 99% of the world's coral reefs before 2 degrees. So that's an entire biome wiped out. And the same happens with rainforests and, other important ecosystems, the whole Arctic tundra and so on, fairly early on. And so humans are actually, obviously, and this is a bit of a truism, I mean, we're a remarkably adaptable species. We've got all sorts of tools and technologies at our disposal. I mean, we can even de-link food production from land by using microorganisms in industrial vats. You have to have feedstocks like hydrogen and CO2 to put into those, but then you've completely de-linked food production from climate. So this is why I wouldn't put 100% risk on civilizational collapse, because there's always the possibility that we can adapt our way throughout almost any imaginable scenario, with the exception of turning the planet into Venus. But even then, I suppose we can go off and terraform Mars, I suppose, and maybe a few hundred people do that for a couple of decades until it doesn't work out. I don't know. I'm indulging in spurious speculation there, but where does the synchronous breadbasket harvest failure come in? About 4 degrees. Where does this issue of biological uninhabitability of large areas of very densely populated parts of the world? That's about 4 degrees as well. So that's why the numbers really go up at that level of warming.
Longtime listeners will know we're especially interested in extinction risks at 80,000 hours. So can you answer for humanity going extinct? So what temperature are we 10% likely to go extinct at?
Well, to extinct humanity, you have to eliminate the last breeding pair.
Mm-hmm. It's a high bar.
It's a very high bar. People can live in artificial environments given with sufficient food for quite a long time. Because of our technologies, we can live in minus 40. We can live in plus 40 Celsius. But I suppose our resilience is comes in the same way as our kind of Achilles heel, in that we are interdependent in incredibly complex societies, which you can't even understand. I mean, they happen dynamically, but no one really knows how the economy works. And so the sort of fantasy that survivalists have of being able to look after themselves and maybe their family in a sort of protected fortress type environment, if you stockpiled canned foods and the zombies don't get you can do that for a decade or two. But
then extinction would just happen later if that was all it depended on.
Yeah, but I do think that humans are one of the last species to go extinct on the planet, not one of the first, because it's just obvious. A, there's a lot of us, so to kill us all is going to take some doing. B, we're incredibly adaptable and can live in all sorts of different environments. We've got all of the technologies, and we've also got advanced knowledge of these impacts, i.e. because we're discussing them now, so we can avoid most extinction scenarios if we don't even have to be that smart to do so. So I'm not too worried about the near to medium term prospects of human extinction. Yeah, I think there wouldn't be much of any kind of life left on the planet if humans were to fail to survive as well.
What about the long-term risk of extinction? So let's say if we get up to 6 degrees, do you have a guess at how probable it is that we go extinct?
I think some humans would survive even at 6 degrees. You need to be in a situation where none of the planet's surface is able to produce crops. Even at 6 degrees, you could produce crops up in the Arctic or on the Antarctic Peninsula or in Alaska or somewhere.
Louis Dartnell on how we could recover without much coal or oil.
You think the first energy source that people should be reaching for, other than fossil fuels, is using hydropower and wind energy, which is basically using these natural forces to turn a turbine, which you can then use either for mechanical work, like people have done throughout history for thousands of years, or to produce electricity. Because if you can spin a turbine, then you've got an electricity source with the right magnet set up. Do you think it would be possible to pre-prepare kind of schematics for simpler wind generators or hydro generators that could be built and maintained with sort of more medieval levels of technology, but which would be actually pretty good at generating energy?
Well, this is it. Hydropower and wind power are ancient technologies. We exploited them first for grinding flour and timber mills. And the idea played with in terms of this sort of steampunk reboot process and the knowledge was, if you combine that medieval technology, i.e. easily reachievable technology, with modern knowledge, which is actually quite simple if only you know the secret to it, sort of electromagnetism and magnets and copper wires, you could create a windmill that looks medieval, but is spinning a generator to create electricity for you. You have this sort of steampunk electro windmill type mashup. And so what you would want if you were to do this genuinely is you could relatively easily, I think, prepare schematics, construction diagrams, blueprints of how to create a turbine which is not quite as efficient as the 100-meter tall ones you see dotted across the countryside, but is still a lot more superior to sort of Dutch 16th century design, and give all the wiring diagrams for the generator and tell people how to make an electromagnet and make the thing work.
Yeah, that it feels like a minute ago you were saying that there's reason to think that some of the solar and other renewable energy sources might not be enough to do some of the critical energy intensive things we'd want to be doing. And in a 2015 article you wrote, Out of the Ashes, which we'll link to, you talk about some specific challenges humanity would face having used up a lot of the readily available coal and oil.
Yeah.
So my colleague, Will MacAskill, is writing he's written a forthcoming book called What We Owe the Future, which you and I actually both contributed to a little bit. And it argues, among other things, that, this is an important reason to get off fossil fuels ASAP so that there's some left over for our descendants in a post-disaster scenario. Does that sound right to you?
Yeah, so again, it sort of comes down to which axioms you want to play around with. What was the exact scenario that necessitated everyone starting again from scratch? What state do you find the world in? And you can play around some of those parameters, like, is there still going to be crude oil underground? Yes or no? Well, even if there's not easily accessible crude oil, there's still lakes of the stuff held in, petrochemical refining stations around the world. So would you be able to get access to those? Or have they all leaked away, or have they burnt? Or, how long has it been since the collapse before you're trying to recover? And oil, I think, is a simpler answer, because I suspect we would struggle to get access to lots of oil starting again. Like geologically, there's not a great deal of oil left because we've got very good at extracting it up until now. Whereas coal is a very different matter. There are megatons of coal. There is plenty of coal left underground, and you would only need to open cast mine it. It's relatively easy to get to. But for that AO1 article, I was playing with the idea of, well, let's imagine that doesn't exist. Let's imagine the collapse happens 100 years, 200 years in the future, or for whatever reason, you are trying to recover society in a part of the world where you're not within walking distance of an open cast coal mine. What alternatives might you go through? Might you be able to use? And I talked about charcoal and how you could use that to smelt metals. And indeed, it's not just a thought experiment, because a large fraction of the steel that's being smelted in Brazil, I think, is done using charcoal. Like, they have a lot of natural wood resources, and they use them sustainably, and they make metal from their forests. So you could go through that process if you needed to. And of course, charcoal is what we used before coal in the first place. You would just be stepping back to a slightly simpler technology and not having to really reinvent anything again.
Yeah, I suppose I came away from the book and that article, also having the same intuition that energy was going to be the big challenge for people after the apocalypse. But I suppose I felt kind of cautiously optimistic that they'd be able to cobble together a bunch of different solutions that you were suggesting and kind of make things work. I mean, in order to get really high temperatures to do industrial processes, you're saying we could use charcoal kind of like we used to. Currently, we can't that's not practical to do on a large scale, because we need that land for food, because there's 8 billion people with mouths to feed. One benefit that would have after the apocalypse is there's a lot less need for food. And so there'll be more land available to grow trees, to make charcoal, to run this kind of stuff. And also, I suppose I just have this economics intuition as someone who studied economics that, the prices will move, charcoal becomes more expensive, we'll economize on our use of these industrial processes that require really high temperatures. And, it'll be horrible, but people will find a way to kind of make things livable.
Yeah, I mean, that's it. But by its very nature, an apocalypse kind of presupposes a mass depopulation event. So there'll be a lot of free land available that is currently growing grain to feed mouths, and you won't even need to plant forests to chop them down for charcoal. It will rewild in a decade or two anyway. The forest will grow back over the farms. So you would have access to lots of wood, I think, at least in the early days as you recover. And then your own population of your rebooting society will start growing again. And you'll start hitting exactly the same basic sort of land use threshold that we started encountering in Britain in, as early as the Elizabethan age. Of we had chopped down all the forests near the cities and towns. And so the price of fuel, the price of wood was starting to go up, which was starting that process towards looking for alternatives, i.e. coal.
Kevin Esvelt on people who want to bring down civilization and how AI could help them succeed.
I imagine some of our listeners will be confused about the idea that people might be trying to kill everyone. I think when I first heard this argument, I found it very counterintuitive and found it, just really hard to wrap my head around. Can you help make it a bit more intuitive? Why would any individual or group want to actually do this? Like kill billions of people, maybe everyone, including themselves?
I think there's a big difference between people who want to kill everyone and people who just want to bring down civilization. And there's one very famous individual who thought this way, Ted Kaczynski, the Unabomber.
Yeah. Do you want to say more about that case?
So I hate to recommend a manifesto written by a mass murderer, but it was pretty darn prescient considering that he wrote it in the early 1980s. He viewed the market system and technology as creating socioeconomic, socio-technical incentives that would eventually cause us to use what he called the immense power of biotechnology to change who we fundamentally are, to make ourselves less than human in order to compete more effectively in the marketplace. And that we would thereby make ourselves increasingly miserable and an increasing travesty relative to what humanity should have been. And this is what got him against technology.
Yeah, that's wild.
And this is a man who went to Harvard, who became a mathematics professor at Berkeley, and then threw it all over to live in a cabin in the woods and develop his philosophy and try to thwart progress by murdering people with incredibly sophisticated mail bombs that completely threw off the FBI for over a decade.
Yeah. I do feel like a real concrete example of a person who thinks this way was necessary for me to actually get behind the idea that it's one thing to have these kinds of beliefs as an ideology, and it's another thing to want to act on them, and to actually act on them. And yeah, I think it just felt like, sure, there are environmental activists who think humans are destroying kind of the beauty of the earth. And like maybe they wish humans weren't even here, but that's very different from like wanting to take the humans that are here, give them a horrible plague and kill them all. Like that's just such enormous suffering. I found it just really unbelievable. So yeah, I feel like the concrete cases made a huge difference. Another one I've heard of is the omnicidal cult Amshunrinko, which I never pronounced correctly.
I don't either.
Do you mind giving the basics of that story as well?
So was a religious movement that arose in the 1980s in Japan, which is not the kind of society that we normally think of at first glance as spawning extremely radical religious movements that launch weapons of mass destruction programs and then try to use them. But it arose as I don't know how typical religious movements are, but it clearly developed in directions moving towards a cult, but one that had a lot of members, tremendously large income stream, thousands and thousands and thousands of members who tithed. But when it was developing, they eventually moved in a messianic direction, the founder did, Asahara, and it moved in a apocalyptic direction. Not that everyone should die, including members of the cult, but very much most people were going to die. The apocalypse was inevitable, and it would be in some ways more humane to bring about the end times of the current world so that the enlightened could build a better one. That was a major, major part of it. And they stooped to targeted murder of rivals' inconveniences relatively quickly as they were explosively growing, because they had to hide an accidental death, which they did. And then it became, there's this one person who is very much in the way. And so they developed a sophisticated form of assassination, which then they botched and had to kill more people and then cover that up. And eventually it became an adversarial thing where the apocalypse will happen, but it won't happen soon enough, and the suffering will continue until we bring it about. So they launched weapons of mass destruction development programs. They bought a uranium mine. They started developing chemical weapons. They started looking for biological weapons. And while there weren't very many that they had access to at the time, they were able to produce botulinum toxin, and they tried to make enough anthrax. And at least as a passing thought, the leader of their bioweapons program, when they went to Africa, he was hoping that they would find someone who was infected with Ebola so that he could purify the virus and spread it around so that it would hopefully transmit and kill as many people as possible.
Yeah, that's horrific.
this was, and this is the most important part. So Ted Kaczynski, you can say, well, he was a mathematics professor. Yes, he clearly appreciated the immense power of biotechnology, even in the early 1980s. He's a mathematics professor. Would he really have been able to do something about it? Well, again, this man is a genius. And he was willing to throw away everything in his life and go and live in a cabin in the woods to pursue his philosophy. Would someone like that be willing to dedicate the time to picking up the skills, which someone of that capability clearly could? I think so, if it was obvious that he could have accessed something pandemic-like that could threaten the stability of civilization.
Yeah.
He didn't have that, so he didn't.
At the time, right.
We should return to the cult, though, because their lead bioweaponeer was one of the original disciples. And he rose high in the ranks in part because he was a graduate-trained virologist out of the University of Kyoto.
Yikes.
Anyone with that level of technical training today has access to reverse genetics protocols that would let them make many of the smaller viruses. If you want access to 1918 influenza, you can just order it from a company that does not screen its orders. And you can follow the reverse genetics protocol that is freely available online. It's open access. I would be incredibly disappointed in the University of Kyoto if a graduate-trained virologist from there specializing in genetic engineering could not obtain pretty much any influenza virus they want. And frankly, many of the others as well. There is just about no chance that they would be unable to successfully perform that protocol. And it does not require that much equipment either. And anecdotes are not data, but my second-year graduate student, who had never done virology before, had done mammalian tissue culture, but only for a couple of years, needed an influenza replicon for her research. And I said, this is a good test case. How about I don't help you, and you just try to figure it out from the protocols online. Do the design yourself, go ahead and do it. She did it.
Wow.
And I decided to check, okay, some of my other students, do you think you can figure out how to design the reverse genetics plasmids for 1918? They all could.
Can you say a bit more about what exactly that entails? Just so I have a sense of actually how hard is it?
Oh, you shouldn't ask me. You should ask GPT-4.
Oh, God. Okay, GPT-4 could probably tell me. Yeah, that is terrifying. Yeah, actually, could you expand on your concerns around AI models like GPT-4?
Well, I have two concerns with natural language processing models, large language models. Number one, they could expand access to existing nasty pandemic class agents. Right now, you need some degree of lab skills in order to turn a publicly available genome into an infectious sample of virus. But we asked students in one of my classes, Safeguarding the Future, non-scientists, to leverage chatbots to figure out how to cause a pandemic. And in 1 hour, the three groups of students, plus the chatbots, came up with 4 of the nastiest viruses known that would be not particularly likely, any of them, but among the most likely that we know of to cause pandemics. Told them that scientists can access these viruses by reverse genetics, producing infectious samples from synthetic DNA constructs, that not all companies do screen DNA to make sure that you're not ordering something nasty, and that all of the companies that do all have their names conveniently listed on a website, so you can be sure that you're ordering from one that does not. And then perhaps even more concerning, when the students asked, well, what if I am a biochemist and I don't know how to do reverse genetics? What do I do? It said, oh, well, you can collaborate, or you can work with a core facility or a contract research organization that will perform reverse genetics for you. You can send them your DNA constructs, which you designed, and the LLM, again, will help you with the design. And you can send that to the CRO, and they will send you back infectious samples. And it even will go into how to test whether the CRO is actually going to sequence your samples to make sure it is what you say it is. So the upshot is the LLM taught non-scientists in an hour which viruses are most dangerous, how to design DNA sufficient to produce them, who to order that DNA from, and who to send it to, and how to do so in ways that could allow them to obtain infectious samples without being detected. That dramatically expands the number of folks who could plausibly gain access to potential pandemic agents. And it's why we need to close some of those loopholes. We need universal DNA synthesis screening, and we need to ensure that those contract research orgs really do sequence all of their customer samples, and not in a way such that someone who has penetrated their network can ensure that the sequencing file is replaced by a false one as soon as it appears, which is again something that the LLMs will talk to you about. So expanding access is one risk, but the other is just that we anticipate that scientists will learn to program biology in ways that, used maliciously, could create worse agents than natural ones. Eventually, I anticipate AI to get as good as human scientists at doing such things. If they are willing to tell the world how one might do that, then they will. And people will ask, and folks who are willing to misuse them will gain access.
Toby Ord on whether rogue AI really could wipe us all out.
Yeah, one way that AI ends up really standing out in your analysis is, so you get this kind of, you divide these 3 steps that you need in order for like everyone to die, or I guess everyone to like lose control of the future. You got to have something that arises and then spreads out over the whole world so it can affect everyone. And then also that it kind of like finishes the job. So you have this problem with like a disease. How does it reach the 1% of hardest to reach people in really remote places and nuclear submarines and all that? And I guess with AI, even if it's like quite unlikely to arise, it's a lot easier to see how these later steps happen because it has this motivation to spread. It's like actually has intent in a way that a disease doesn't.
Yeah, or it's at least easier to see at some very high level because of the intent that is optimizing to, is actually trying to wrest control of the future. A couple of things that are useful to explain though. A lot of people don't quite see how the scaling up would work. And because they're thinking about robots, there's probably less so among your audience. Yeah. But ultimately, without any kind of robotic manipulators, AI could, I mean, if you think about Stalin or Hitler, people who scaled up from like being one person to being in control of a significant fraction of the world's military power, you know, most of the orders of magnitude up to the whole power they scaled. They did so through manipulation of other humans. And you could imagine AI systems on the internet spreading to millions of unsecured computers and trying to manipulate millions of people who are on the internet into doing their physical bidding by paying them or threatening them or enticing them, promising them things in the future. I do think that...
It seems like, even humans aren't super sophisticated sometimes seem to pull this off of like, influencing very large numbers of people to do strange things.
Yeah, so I paint a picture of this in the book of perhaps how this could happen. It's not meant to be the only picture, but it's meant to show how by building up a whole lot of abilities that humans have already achieved, things that are clearly within human level of intelligence, basically building a large-scale criminal underworld, that AI going through that route could scale its way up to the power of a nation state or something, and then be almost impossible to eradicate as well. So that's a bit of an explanation of the scaling step. As to the final step, I'm not claiming that AI, that it's an extinction risk. I think that it's not clear that even an AI that went badly wrong would want to kill everyone. I think that humans are the most interesting thing that it would have access to, possibly the most interesting thing in the affectable part of the universe. But that doesn't make a substantial change. Yeah. I don't think they'd be saying, okay, humans, fill the universe with love and flourishing and all the things you want. They would, our future would be radically curtailed if we were just there as something
at the behest of
at the behest of the AI. And whatever goal function it was programmed with, it would be attempting to achieve that, using us as an interesting kind of piece of evidence to help it better achieve that goal, rather than listening to us and doing what we want. So it would count as an existential catastrophe, though I'm not necessarily claiming it would be an extinction catastrophe.
So The Precipice was this book that you wrote in 2019, 2018, came out in 2020. It, I guess, explored the science behind all of the different major threats to humanity's future, pandemics, asteroids, AI, of course, nuclear war, that sort of stuff. And of course, there's been lots of developments since then. And I think last year you wanted to look back and say, over the 5 years since you wrote it, what have been the major changes in the picture? Is humanity in a better situation? Is it in a worse situation? What have been the major changes, I guess, in particular on AI, where so much has been going on?
Yeah, so obviously lots of changes in, say, pandemics. We had COVID kind of hit us and so on, mRNA vaccines, so on and so forth. And nuclear war, the prospects of that were, felt like a distant memory back in 2019, and now it's become more of a realistic possibility. But AI is where the most changes have happened.
So back in 2019, I think in the precipice, you estimated that the chance of humanity losing most of its potential future value due to AI in this century, I think, was around 1 in 10. Would you say that that number's drifted up, or has it drifted down?
I'm not sure. For a lot of the other risks, it was kind of easier to see whether it's gone up or down. And for this one, I think that, we've really been gifted a relatively good situation in terms of the way the technology has panned out, in that it's this technology that imitated human values and human reasoning and so on, by training on this huge corpus of human data. I think that has just been tremendously helpful. And the fact that it's not an agent by default, real gifts. It wasn't that we steered towards that because we knew that would help with safety. It's just that earned out to be the easiest way. And I don't think we quite recognize that enough, that the biggest effects on whether we're safe or not have just come from somewhat random nature or random aspects about this technology landscape rather than a deliberate attempts to steer it. But I am very concerned about the racing, and I'm concerned that we've seen evidence that the players who are trying to make these systems are are ultimately going to cut corners in order to win these races.
Joan Rohlfing on why we need to worry about more than just nuclear winter.
So the mass use of nuclear weapons would be the greatest atrocity in human history and the greatest setback to that humanity arguably had probably ever suffered. So by any normal definition, that the scale is enormous. But I guess, people who I know who are particularly concerned with extinction and existential risk have always been very interested to understand what would be the flow-through consequences from that in order to see what would be humanity's chances of bouncing back over a period of decades or centuries after the use of nuclear weapons. So they're very interested in questions like, how bad would the nuclear winter be? How long would it last? How many people would die? And things like that. I know that you maybe think that the people who I'm familiar with reading on this maybe are slightly prioritizing wrong the question here, or perhaps misconstruing the issues. So I'm very interested to hear what you have to say about that.
So when I think about the long-term impacts of nuclear use, what I would really urge the audience to think about is not just an extinction event, but, what happens when we have a major event to the resilience and ability of civilization to flourish. So I would reframe it slightly to say that in addition to civilization being extinguished, that we have to worry about the disruption of the long-term potential of civilization. And I'm reminded of the excellent graph that Luke Muehlhauser put together that shows so vividly the massive post-industrial revolution gains across the variety of metrics like life expectancy, GDP per capita, percentage of people not in poverty, energy capture, et cetera. It just takes off with the Industrial Revolution. I can imagine a major nuclear event pushing us, back to a point where we've lost all those gains. And it's not clear whether we recover them on the same trajectory. I think there's, we just don't know. We don't know how we recover, how quickly we recover, whether we can recover. So it's not just an extinction event that I would argue we need to worry about. I would also say one of the things I've noticed is that many in the EA community, I think, are overly focused on nuclear winter as the only trigger of a possible extinction event.
Yeah.
And what's clear to me is that we need to worry about a lot more than just nuclear winter, not to minimize. I mean, nuclear winter would be a horrible thing if it happened, but NTI has been doing a landscape analysis to better understand the gaps in our knowledge of nuclear effects of a major nuclear exchange. And what has become clear is that while we have pretty good grip on the prompt effects of nuclear weapons and a little, some excellent research done on the likelihood of nuclear winter being triggered, I know there are uncertainties there, but some really excellent work informs our understanding of that. There's almost no work that has been done on the dynamic cascading effects of, a series of impacts on loss of critical civilizational systems, critical infrastructure. What happens when you're losing power grids, banking systems, the ability to produce water,
trade.
Yeah.
To move goods, yeah.
So imagine these things happening all together, and people can't get food. And I mean, it's inconceivable to me that our governments function the way we would hope and expect them to show up with services when people are just fending for, to provide for their basic daily needs. So I think there's a lot of interesting work that needs to happen to understand the knock-on effects, how these, in a highly interdependent world, when you start losing key systems, how do things fall apart over time?
Another audience member wrote in, how much of our effort should be spent on preventing a war and how much should be spent on building resilience to mitigate the harm and speed recovery? And I guess they might be thinking of the kind of project like AllFed, the Alliance to Feed the Earth in Disasters, which is trying to find ways of potentially producing enough food to sustain everyone through a nuclear winter.
So my own view is both are important, but I would put much more weight in the prevention for a couple of reasons. One is I think that's our highest leverage, right? If we can prevent the catastrophe from ever happening, then we don't need to worry about the resilience. I also think when I think about resilience on the scale we're talking about across the wide range of systems that would be required, it is a really, really hard problem. If we think reducing nuclear risks is hard, now imagine redesigning, fundamentally redesigning, decentralizing all of our critical civilizational systems is kind of what would be required to build sufficient resilience to not worry about critical systems failures. And so I'd want to think about, well, what does that look like for the power system, for the banking system, for international trade, for food production? There are just so many different layers of system that would require massive rethinking of how those systems are structured, massive reinvestment in rebuilding them, redesigning them, changing governance structures. I do think that's important, and we should understand and give thought to those questions, but that feels like lots more daunting and longer term and still with no guarantee of success. By the way, I think it's also the reason to go back to an earlier observation about us not really fully understanding nuclear effects on all of these systems. It's why investment and research in better understanding nuclear effects is so important, because it would help point us to what we need to do to strengthen resilience.
Yeah.
We wouldn't even really have a clue how to go about resilience right now because we don't know where the biggest vulnerabilities are.
Annie Jacobsen on the rings of annihilation and electromagnetic pulses from nuclear blasts.
Let's talk about those nuclear effects. Let's talk about what nuclear weapons do to people and to things. These are effects that I source specifically from Defense Department documents. The Defense Department has been keeping track of all of this since the Hiroshima and Nagasaki bombs. And we exploded hundreds of atmospheric nuclear weapons during the Cold War, the effects of which were measured for these documents. And I myself interviewed a number of these nuclear weapons engineers who armed, wired, and fired these weapons, and I thank them in my acknowledgments for teaching me so much about this horror. The idea of what a nuclear weapon does to people begins with this thermonuclear flash of light, and I describe the effects of the 1 megaton attack on Washington, D.C., which sets off this horrible scenario as 19 football fields of fire. That is the center fireball. It will obliterate everything in a 1 mile square radius, everything. Nothing will remain. No cellular life, nothing. All humans will be turned into combusting carbon. And then you have to deal with the fact that there will be this dense wall of air pushing out from the center point. That is the blast, 3 miles out in every direction, knocking down everything. Engineered buildings change shapes, bridges, roads will melt into pools of essentially asphalt lava. That thermonuclear flash has set everything in the line of sight on fire. And for the book, I interviewed one of the world's experts on nuclear firestorms. Her name is Lynn Eden. She's a professor emeritus at Stanford University. And she talks about how the energy from the mass fire that will ensue is 15 to 50 times greater than the energy from the initial blast.
Okay, so the fireball that you've described is what happens kind of right at the center of the diameter of the nuclear detonation. But there are kind of other rings further out that also have really horrific consequences for all of the kind of life in those areas too. Can you talk about what happens in the second ring?
I mean, the short version goes like this. Ring 1, total annihilation. No cellular life remains. Ring 2, another 3-mile diameter out. Everything is ablaze. Ring 3, another 3 or 5 miles out in every side. 3rd degree burns among almost everyone. You are talking about people who may have gone down into the secret tunnels beneath Washington, D.C., escape routes from the Capitol and such. People are now broiling to death. People are dying from carbon monoxide poisoning. People who followed instructions and went into their basement are dying of suffocation. Everywhere there is death. Everywhere there is fire. People are dying left and right of blood loss. Imagine the projectiles flying through the air after several 100-mile-an-hour winds overtake Washington, D.C. Here's an image which you will not be able to get out of your mind. The mushroom cloud, that iconic mushroom stem and cap that represents a nuclear blast, that mushroom cap and stem, when exploded, when a nuclear weapon has been exploded on a city, that stem and cap is made up of people, what is left over of people and of human civilization.
Oh my God. And do you mean that in the sense that it's basically kind of the incinerated particles of people and buildings and everything, and that's being kind of lofted up as...
That is precisely what it is.
Yeah, that is...
I love your reaction because it was exactly my reaction when I first learned that. You think to yourself, that is gruesome beyond gruesome. Then you ask yourself, is that really true? And then you think, well, of course it's true. What else would it be?
Further out, people survive, but one might imagine, and I used to think, that if you're not in the direct vicinity of a detonation, things might be kind of okay. But you paint a picture of what things are like for those survivors in other areas, and it's actually, really terrifying. It really changed my perception of what would happen, I don't know, in Wisconsin or Texas, where I grew up, which I don't think that, my particular neighborhood in San Antonio, Texas is that likely to be the target. But everywhere in the US will be drastically impacted in ways that I really had not put together. So I found that extremely, extremely sobering.
When you look at the target list for the United States, and again, these are sourced from sort of very obfuscated maps that have been released over the decades from the various organizations, not just the Defense Department, but FEMA, the Department of Energy. You realize very quickly that everything is a target. If you're talking about 1,000 nuclear warheads from Russia coming at the United States, in the words of Professor Brian Toon, who is the world's expert on nuclear winter, who an original author of that paper back in the 1980s, who I interviewed for the book, and he explained to me that if you are in any kind of a city, not just a major city, I'm talking about small cities, any place with a military base, in any place with an industrial capacity, you are a target. There is a nuclear weapon pointed at you. And remember, this is happening over minutes. So it's not a long amount of time that the survivors get to realize how horrific this all is. I did an interview with America's first cyber chief, General Tuhill. He was appointed by President Obama. He's able to tell us a little bit about this idea of what happens to the United States of America, the chaos that ensues, the mayhem, the madness in the seconds and minutes after the initial 2 nuclear strikes from North Korea. Because given the age of social media, someone is videotaping this from even 25 miles out or on an airplane far enough away that it wasn't taken down by the EMP. And these images begin to circulate. This is not just plausible, this is probable. And then the world knows what has happened, and there begins a scramble for cover, a scramble for escape, a scramble for ... And I describe that in the book.
Yeah. And yet, as you've already said, FEMA has no plan to help people, partly because no one will be, it's not like FEMA employees will be out there with the ability to help. An EMP plus the fallout, I guess literally and figuratively, of nuclear detonations will mean that no one really has anything remotely like the normal kind of emergency infrastructure or normal anything. Actually, we haven't even touched on EMPs yet. So yeah, can you talk us through what would happen if a nuclear weapon were detonated in space in order to create a super EMP or electromagnetic pulse?
So a super EMP is a 3-phased electromagnetic shock wave so powerful that industrial strength surge suppressors and lightning arresters, all of which have been designed to block this kind of high voltage spike, they all become rendered useless at once. A super EMP happens by detonating a nuclear weapon, and it can be a small nuclear warhead in space 300 miles above the United States, would do unbelievably catastrophic damage to the entire country. I went to the world experts to drill down on this. As I mentioned, General Tuhill, Obama's first cyber chief, and also Richard Garwin. Not only did he design the first thermonuclear weapon, Ivy Mike, but he wrote the first classified paper on EMP back in the 1950s. It's still classified. They both confirmed with me that the collateral effects of this EMP strike are what would be so deadly. And when you, in simple terms, what essentially happens is the whole electrical grid would shut down. It would be a catastrophic failure, a sort of failure of the systems of systems, ultimately centered on this one concept, I think, that listeners might be able to wrap their head around, which is there's a system in the United States that pretty much runs everything, and it's called SCADA. That stands for Supervisory Control and Data Acquisition. It sounds like a mouthful, but what it really is a system of systems, of computers and people that control all the systems of the industrial underpinnings of the United States. So imagine losing control of railroad routers, of the lift gates on dams, of gas and oil refinery transmission centers. I mean, you're going to lose assembly lines. You're going to lose air traffic control, port facilities, fiber optics, GPS, hazardous materials. I go on and on in the book about what happens. It all happens in a second. Never mind that at least at minimum 10% of all cars in the United States will stop running simultaneously.
The passage that struck me most, I'll just quote: "There will be no more fresh water, no more toilets to flush, no sanitation, no street lights, no tunnel lights, no lights at all, only candles until there are none left to burn. No gas pumps, no fuel, no ATMs, no cash withdrawals, no cell phones, no landlines, no emergency communication except for high-frequency radios, no hospital equipment." It's really the end of everything.
It really is. And when I was reporting this book, really drilling down on the scientific facts about EMP, because the issue has tragically been politicized. Some go so far as to make fun of people who refer to the EMP threat. This despite the fact that the world's experts pretty much unilaterally agree, and I'm talking about the Richard Garwins and the General Toohills of the world, when we're talking about super EMP, they agree the catastrophic possibilities here. Imagine me writing this book, drilling down on that, wondering how I might be able to bridge the information gap between people's preconception and what experts say is reality, coupled with the fact that almost no one had ever even heard of this threat. And then, shortly before the book publishes in March, you learn from the U.S. intelligence community fears that Russia is considering putting a nuclear warhead in orbit. This is precisely what an EMP would do.
David Denkenberger on disruptions to electricity and communications.
I think there's another whole class of catastrophes that could disrupt electricity or infrastructure. And one of them would be solar storms. Another is detonation of nuclear weapon at high altitude, causing an electromagnetic pulse, which could destroy electronics. Another one would be a coordinated cyber attack, perhaps enabled by narrow AI. And a fourth one would actually be an extreme pandemic where people are too scared to show up to work at critical industries like electric power plants.
Yeah. Do you have any thoughts on whether we should be more or less worried about those things versus the risk of a nuclear war?
Well, I think, as you've pointed out on other shows, the natural risks are probably lower probability. But the interesting thing about solar storms is that it's a new threat in a way, because a solar storm 1,000 years ago is not going to hurt us. But now that we have this electric system that could be damaged, that's a newer thing. So I think there's some threat there. I think it's unlikely to be global. But similarly on the food production disruption, I think even if we have a regional disruption of industry or electricity, that's a significant shock and would also likely be accompanied by a food production shock.
Is there much to say about how swiftly we might be able to respond to something like an electromagnetic pulse that damages the electricity grid? Do we have a good idea about how much damage that would do and how hard it would be to fix, or are we kind of left to some extent to speculate about that?
Well, there's some debate, and former guest David Rudman has done some analysis on this. We're actually working on a global analysis looking at the impacts of a solar storm. But I think that, in the case of the solar storm, there might be something we could do ahead of time if we detect it. We might have a few days and be able to turn things off. The EMP is tough,
It's by nature a weapon that would, I guess it would be designed to be a bolt from the blue. That would be the aim.
Right.
Are we sure that if you detonate a nuclear weapon at high altitude, it has this effect? Has it ever actually been tested?
It has, and in fact, we kind of accidentally discovered how destructive it could be in the first test. It had because it interacts with the atmosphere, it had a much greater radius of impact and disrupted electricity, I think, on Hawaii, very far away from the original test.
Wow. Okay. Interesting. Okay. So we discovered this effect basically through testing. Have we ever gotten to the point where it's we're going to break electricity grids or test it at that level?
I think there was a test in the Soviet Union that was closer to people, and there was disruption. And some people have said, well, there may be these super EMP weapons developed at some point, and they could be even more destructive. But even just regular nuclear weapons are quite destructive. Modern society is extremely dependent on electricity. And so there are these interdependent webs of causality here. So if you lose electricity, you lose typically a lot of fossil fuel production, you lose communications. And so basically you'd have a collapse of industrial civilization. Now, what we want to avoid is the full collapse of civilization, which includes cooperation outside of small groups. But if we lose this industrial production, then there are some immediate needs. Alfred has a catastrophe planning expert who used to work in the Royal Air Force. And he has this kind of rule of thumb that you'll die in 3 minutes without air, 3 hours without shelter, 3 days without water, and 3 weeks without food. And
So fortunately, we're still going to have buildings, but we need to heat those buildings. And then we also need to provide water very fast. So we are looking at how many people live close to water such that they could not have to move locations and still gather water. But then eventually it's going to impact food, because right now our system is very dependent on artificial fertilizers, pesticides, tractors, irrigation, etc. And at least the sun would still be shining, but it would require dramatic scaling of hand or animal tools to farm, which we're still working on. But we do have some estimate of the direct impact on agriculture of losing these industrial inputs. It's something like cutting production in half. Now, it could be, especially if there's a trade disruption, and trade would be more difficult, of course, in these scenarios, that the just hand farming is not going to produce enough food, especially regionally. And then it could be that you want to do some of these more resilient type foods.
I guess an EMP, it's at least somewhat localized. Well, I guess you could potentially have people setting them off all over the place, but potentially it could be a local thing. And I guess solar storms as well, they tend to target particular parts of the Earth that happen to be hit by them. I guess in that case, I wonder whether you just want to move all of the people to other places where the equipment is still running and the electricity grid is still up. Maybe that's the best way of producing lots of food, is just to get people to places where it's going to be easier to work. Does that sound plausible?
Yeah, that's one option, assuming that people and then there's enough cooperation that they could handle hundreds of millions of migrants.
Yeah, interesting. Okay, so we've talked a bit about electricity. You also raised the issue of communication going down. How long do you think it would stay down, and how severely would it be down, and how big a problem might that be?
Well, again, it depends on if it's regional or global. And I think even though it's unlikely, it's possible that there could be multiple EMPs around the world. You look at a full-scale nuclear war between Russia and NATO, then you have most of Europe. It could even spread to other nuclear powers. I mean, that's the majority of the world's population and infrastructure.
Yeah. So it's a lot of people covered, potentially. Couldn't people still communicate by, I don't know, I guess are there sorts of radios that work for this if you really needed to? Or I don't know, maybe the mail? I guess the mail might be down, but yeah.
Yeah, or mail would be slow on horses and such. And so one thing we've looked at is shortwave radio, or sometimes known as ham radio. And they use a frequency that you don't need to produce that much power. You can have a $20,000 system that can actually communicate across an ocean. And so it could only be a few $1 million to have a backup communication system.
Yeah.
And this would be extremely valuable, especially if the catastrophe were abrupt, that we didn't have the internet to learn about what to do in this circumstance, so that we could get messages out of what to do, how to meet basic needs, at least in the first few weeks, and then we'd buy us some more time.
Yeah. I guess it seems like most countries do some stuff to prepare themselves against disasters, and it seems like this would be well within the budget to have ham radios in major cities for this purpose.
There are some, and I think the issue is that countries will have systems for themselves, and not every country has it.
Yeah.
So what we're interested in is doing a global system backup. We've also done a cost-effectiveness analysis for these interventions, and it's actually only for the long-term future perspective. But I think there are some mechanisms that this type of a loss of industrial civilization could cascade downward to loss of conventional civilization. And I mean, the last time we were at hunter-gatherers, there were only a few million people on Earth. So, 99.9% mortality. And, again, are we sure we're going to recover from that?
Yeah.
And in a way, I think it would be less expensive to get ready than for the resilient foods for nuclear winter, because we don't have these expensive factories we need to pilot. We won't be able to make factories. So the experiments will probably cost less. But we do need this radio backup system. But again, a few $1 million or so gets us pretty far. So we're talking, again, in the range of something like $100 million.
Luisa Rodriguez and how we might lose critical knowledge.
I suppose, so in the situations where there's far fewer people, like 99% of people dead or something like that, how much will we struggle to access knowledge about, say, medicine or other topics where it would be really potentially useful to remember stuff from the pre-apocalypse?
Yeah. So I suppose, luckily, there is kind of an inverse correlation between how valuable knowledge is and how few people have it. This isn't perfectly true, but mostly, like, even though there are many fewer brain surgeons than general practitioners or something, brain surgery is just less important than all the knowledge that general practitioners have.
Yeah.
And that just like does a lot of work. So we'll lose lots of sophisticated knowledge of some types of medicine, but it's hard to imagine why we'd lose germ theory and even like some basic things that will make maternal health better during childbirth, for example. And even that will be a huge improvement on where our ancestors were at similar population levels.
Yeah. How many people know things like how to keep a car running or like how to run a power station? Maybe think about that, or like how to run the electrical grid or get that back up and running. Things that kind of stand out as maybe there's not enough people in that group.
Yeah. Those were good candidates for, like, I called them critical skill sets. And I guess it's just kind of hard to think about. So one reason it's hard is like no single person knows how to run a power grid. It's like really distributed knowledge. And leadership at a plant might have more knowledge of the bigger picture, but it's still distributed not just in the many individuals who like know the different steps, but also it's going to be in like manuals, and some of those will survive. So it's hard to think of like really critical knowledge that's super concentrated in like a couple of people. And I try to do some back of the envelope calculations to be like, what is concentrated and what could we lose? And I would love for someone else to try doing this research in a way that produces more interesting results than what I did. I ended up doing things like, maybe like we think advanced chemistry would be really nice to have. So I was like, how many PhD chemists are there? And try to think of it this way. And when you think of it that way and you just make some naive assumptions about where they live, you still have lots of PhD chemists, even in a world where 99% of people have died.
I guess it might be getting down if you're at the 99.99.
That's where you start to hypothesize. I think I just don't know enough about how critical infrastructure works to be like, what's the job? What's the one job that's like scarce but super critical? But you can think about it just kind of theoretically. Like maybe there are some jobs like that, and you do get to the like 99.99% population loss level before you start thinking that there are jobs like that you'll definitely lose. That kind of opened this thread of like, how does knowledge like that persist over time? Like, does it degrade? Does it get taught? When it gets taught, do we like lose some important bits? Maybe there's some evidence that when you get really small populations and you try to pass down skills between generations, in a way you're like making copies of information. And when you like try to teach it, if the number of people learning it is small enough, the copies will get lower and lower fidelity. People will like...
Because there's not enough people to cross-reference and correct mistakes, maybe?
Yeah, I think that's part of it. And another one is the more people you have, the more people innovate. And then you get like improvements that make up for losses in like the basic skill. But yeah, I think the way you can think of it is if someone's teaching you to shoot an arrow, lots of people will be worse at it than the master. And you need enough people learning it to have some people
in the next generation, there's someone as good
exceed.
as the best person in the previous time.
Some examples of knowledge degrading over time that were kind of interesting. I think one was, Polynesian islanders lost the ability to build boats and then got stuck.
That's a big problem.
Yes. Yeah. Apparently, this is the way in which at least one group of Tasmanians lost the ability to build fire.
Kevin Esvelt on the pandemic scenarios that could bring down civilization.
So you've written a paper describing two scenarios so catastrophic you think they could cause society to collapse. So there's what you call the wildfire pandemic and the stealth pandemic. And I want to talk about both of them, but I want to start with the stealth pandemic scenario. Can you say what happens in the stealth pandemic scenario?
Imagine a fast-spreading respiratory HIV. It sweeps around the world. Almost nobody has symptoms. Nobody notices until years later when the first people who are infected begin to succumb. They might die. Something else debilitating might happen to them. But by that point, just about everyone on the planet would have been infected already. And then it would be a race. Can we come up with some kind of way of defusing the thing? Can we come up with the equivalent of HIV antiretrovirals before it's too late?
How hard is it then to convince, I don't know, whoever you need to convince, politicians, other academics, society to like actually take action, given that like no one's going to be having any symptoms. Everyone's going to feel fine. And you're going to be like, no, but we think there's a weird thing. And we think everyone should invest loads of money and effort to try to figure out what's going on with this weird thing. Is that going to happen?
Well, I guess one question is, who would need to support us for you to believe it, for the most skeptical member of your family, the most conspiracy theory minded person to believe it? And those are two very different levels of burden of proof. But
they are.
We don't, the horrible thing is we don't need everyone to believe us. We need enough essential workers to believe us such that we can protect enough people to keep civilization running, is the horrible answer. Obviously we want to save as many people as we can. We need to provide tools that will allow them to protect themselves if they believe, even if many other people living around them don't believe, even in the same family. That's hard, but it's not impossible.
Right.
And as to who do you need to believe? Well, you probably need at least a plurality of scientists. And ideally, you would get near unanimity in the scientific community. Now, scientists are like people, any other group of people, right? It's very difficult to get 90% of scientists to agree on anything at all. We can always argue over something, but if you can get about 90% of life scientists to look at the genome and say, oh my God, that's probably good enough. And maybe you need to run experimental tests, that it's behaving the way you expect in the cell types that you expect. You would need to track down people who are infected and get their permission to run tests on them, verify that it's doing the things that you would predict based on all of your analyses. You certainly, at a minimum, need to convince your defense establishment.
It's interesting that so much of the problem is like the sociological side. It sounds like we're making good progress on the science side, but this then how do we get the people to do the things does sound extremely challenging. But it also sounds totally right that if you've been in conversation with the defense community for 5 years, you've shown them what your system is like and they're bought in, and you're like, at some point we're going to come to you and we're going to say there's this pathogen that we found and it looks really bad. We're going to need you to have a plan already, that they might have a plan, and that plan should make things go much, much, much better than if they were just one, in some disbelief, and two, just totally surprised.
But that does bring us to the last point about the stealth scenario. The scientific community is not necessarily going to be willing to just go into their labs like normal, even given this motivation, because they believe that it's out there and they would be at risk and putting their families at risk. So this underscores the importance of ensuring that there is good enough protective equipment and just healthy buildings initiatives to block transmission in buildings, perhaps starting in research labs. I mean, one of the things my lab did during COVID is very early on, I figured, oh, this is obviously airborne. And therefore, we knew pretty early on that there weren't as many super spreading events in airplanes as you would expect. Therefore, one complete air exchange every 3 minutes is your target. What would it take to get our laboratory's rate up to that? And we just ordered 20 consumer grade HEPA air purifiers.
HEPA filters, nice.
And installed them in the lab and ran them full blast and had as safe as planes, and then wore masks. And sure enough, we had 0 infection events.
Wow.
But you're going to need to do something like that, ideally in advance. And again, that was with COVID, which wasn't to young and healthy people all that serious. Although we were pretty scared at the beginning because everyone was and we didn't know for sure. But if it's something that is much worse than that, you're going to need enough reliable protective equipment for people to go out there. And this is also true. The better you are at persuading people of the risk, if they're essential workers, then you need protective equipment to persuade them that they can still go out there and keep everyone alive. Because I feel like that is one area where COVID taught us that some people are more essential than others. But we defined essential at a level that basically let society continue on more or less as it had, with, some restrictions on the sides, a few inefficiencies, but otherwise basically that. We need to be a little bit more serious about it. We need enough reliable, no fit testing required protective equipment like current pappers, but better and cheaper. Either we need enough for everyone at the outset, which would be the great way. Like, that's the way that any nation can just be like, yep, we are totally ready for whatever comes. If it's stealth, we may not be able to persuade everyone to wear it, but it will be available for everyone. But if you aren't willing to put that in that kind of investment, you really need to know who needs it. And this is more important for the other scenario.
Okay, let's move on to the wildfire pandemic scenario. Can you describe what happens there?
Wildfire is fairly simple. There is a pandemic so contagious that we can't stop it. And although COVID showed us that most of society can in fact stay home and avoid getting infected in extremis, there's quite a lot of people who can't. The people who need to ensure the continued distribution of food, water, power, and law enforcement. Those folks still need to be out there. Some of them need to interact with other people. Any pandemic agent that is contagious enough to spread through those people and take them out will disrupt essential services and society will collapse. I mean, many of these essential workers are some of the most vulnerable members of society. And yet they're the ones who literally keep everything running. They are the ones who keep the lights on, the food on the table, the water in the taps, and order in the streets. And although you can imagine that you don't necessarily need the police per se, if you're willing to call down martial law and have the military do the same thing, you do need someone to be handling that. So the defense against wildfire is very straightforward. You need enough units of pandemic-proof personal protective equipment that don't require fit testing to be sent to everyone who is going to need it, in the sense of the people who really do need to go out there and do their jobs, or everything falls apart. All those people need protective equipment. If they have it, and all of the people who make the protective equipment have it, then we can weather the initial surge while everyone else locks down. And then we need to have enough protective equipment for the next group of essential workers. So the primary are the ones who directly deliver those key services. Secondary essential workers are those that repair the equipment that the primary ones rely on, or produce the kinds of supplies that the primary workers need. That is, the secondaries aren't needed immediately when the pandemic hits and everyone is terrified. Because again, this is very different from COVID. This is if you get it, you are very likely to die. Just a wildly different setting. People would take it way more seriously. And the risk, in fact, is that too many people are no longer willing to go out at all under any circumstances, because they quite reasonably believe if they get infected, they will likely bring it home to their families, and then their families will die too. So we just need enough for all the primaries, and then we need to ensure that we produce it fast enough to deliver it to all the secondaries in time for when their services are required. And the really harsh truth is, if you're trying to ensure that civilization survives, you don't necessarily need medical workers. You don't need doctors and nurses and physician's assistants and all of the support that they require. Nor do you need elder care, nor do you need social workers, nor do you need any of those things. Because if those people aren't there, lots of people are going to die. And that would be horrific and tragic. But from a very cold-eyed, cold-hearted perspective, that's better than almost everyone dying, which is what happens if you lose the truly essential services. So a sane government will invest in enough units for primary and secondary essential workers and all of the life-saving workers. But if they don't, we at least need to know who those primaries and secondaries are, and at an absolute minimum, ensure that we can get enough units to them quickly. Now, the United States has this strategic national stockpile for essential medical goods and medical countermeasures and all kinds of disaster preparedness type stuff. Bluntly, I don't want the strategic national stockpile to have the pandemic-proof PPE. I mean, I would love it to have it stockpiled, but they're not very good at getting it out of the stockpile and into people's hands. Whereas we know for a fact that the private sector can do that reliably, probably on a next day basis, but certainly within 3 days.
Amazon Prime.
Amazon Prime. So we know we can deliver whatever to whoever very, very quickly using some services in society. And it is not obvious to me that the strategic national stockpile can do that. Now, perhaps they should just talk to Amazon and say, here is where it's going to be stored. You need to get it into your distribution network for delivery within, say, 5 days. Absolute maximum. Fine. But the point is we need to know who are the essential workers. We need enough, we call it P4E units, pandemic-proof personal protective equipment, P4E for short, for all of those at a minimum, and preferably for all life-saving workers, and have lists of their addresses. And of course, essential workers includes all the folks who are going to be doing the deliveries, because everyone is going to need food. Are people going to need to go and pick up their food, or can we do online delivery? But if we have that, if we have the lists of who needs it, and we have the equipment, and we have stockpiled enough materials so that we can last until we have equipment for the additional groups of workers who are needed to, again, repair the essential equipment, provide the supplies and stockpiles of the new stuff where we don't have enough in reserve, then we'll be fine. Wildfire is an obviously solvable problem using our current capabilities, current technologies. How much does it cost? Well, it depends on how low you can get the price of P4E. I'm pretty confident we can get it down below $250. But the trick is we also would ideally want it to be comfortable. And of course, it needs to be reliable and it needs to be convincing. People need to believe that it will work, because if people don't believe it works, it doesn't matter whether or not it actually works. They're not going to go out there and keep everybody alive. Or probably not. We can't assume that they would. We do have some historical data to rely on here, which is we can look at the SARS-1 outbreak, which is about 10% lethality. And there was a lot of pressure on nurses and doctors, especially the ones who had families and young children, to not go to work. And you definitely saw a bias towards the young and childless as the ones in the wards. So at 10%, that's what you see. How high does it need to be a wildfire? Well, I don't know, but it would need to debilitate enough of the essential workers that services would collapse. That's the only way that you actually lose civilization.
How hard is it going to be to convince people not to give life-saving healthcare workers P4E so that they can go on doing life-saving work? That sounds like the kind of thing people are going to find really, really objectionable.
And I totally agree. It's just that people are bad at making trade-offs. And in any scenario where you can afford to, you absolutely should give them P4E. There's no question. So I'm not for a moment going to argue it. I'm just going to point out that suppose that we fail to bring down the cost of P4E and you just needed to buy it now. Call it $1,000 a unit. Okay, how many units are we going to buy? So in the United States, in terms of primary essential workers and then the very near-term secondaries, probably can get away with 20 million or so. So there's $20 billion. Last year, for context, Congress gave the Department of Defense $30 billion more than they asked for. So we could have just used that bonus that Congress handed to DoD to completely immunize the United States against wildfire pandemics. That's what I mean. This is a totally solvable problem. And then figuring out who needs it, like this is not super challenging. We did it on the fly for COVID, just under much reduced stringency in terms of who was needed to be essential. We can figure all this out. It's not that much effort. It's not that expensive. But if you wanted to get all the healthcare workers now, that's like 16% of the workforce on top. So there you're looking at probably more like 50 million instead of 20. If you want to get all of the medical workforce and the folks who support them. That's just a lot more people. And I guess that's if you include social workers, elder care, all of that jazz. So should we do that? Yes, absolutely. It's just that's an extra $30 billion. Should we spend that? Yes, we should. But if we're not, then it's really important that when the time comes, we recognize the fact that you ship the units to the most essential people. And those may not be medical workers.
It sounds like you don't have some exact percent lethality that you need to have to definitely be in a wildfire scenario where people are unwilling to go to work, causing something like civilizational collapse. I guess I've heard something like the reason we haven't seen pandemics that have both high transmissibility and high lethality before in a way that causes this kind of particularly horrible situation is because those things come with evolutionary trade-offs. Is that right?
That's probably right for some pathogens and not for others.
Okay.
So certainly the Black Death had both. Certainly smallpox has both, or at least the variola major strain is 30% lethal and R naught between 3.5 and 6. So is that in wildfire territory? That's the only one, though, that we label as being probably transmissible enough. Because the Black Death, even if it weren't susceptible to antibiotics, was just not transmissible enough in the modern world. So the only one we know about is smallpox, that we think would possibly be wildfire level today at 30% lethality. And it's worth noting that the Soviets almost certainly enhanced it to the point where when there was a accidental outbreak in the Uralsk region, out of 10 known victims, the 3 who were unvaccinated all died. And it was transmitted efficiently by vaccinated people, which wild-type smallpox does not do. So clearly it is possible. And again, this caused an outbreak. They managed to contain it. They shut down all the trains. They got it under control. Once we get good enough at programming biology such that these other capabilities can apply, we just don't know what is going to become possible. I would not assume that whatever natural trade-off exists between contagiousness and virulence is necessarily going to always apply. And what's more, even if there is a pathogen that is not evolutionarily stable, that is, mutants will accumulate that will, say, reduce the lethality over time, that doesn't mean it can't crash civilization first.
And just to make sure I understand the evolutionary trade-off, is it basically at some high enough level of lethality, it can't actually spread very far because it's killing people before it spreads?
Yes, it seems to be linked to whether or not it kills you before you have a chance to transmit it. If the transmission window ends and then it kills you, then there's no potential limit. So some known pathogens often kill you after the transmission window is mostly closed. And so those ones don't seem to be particularly subject to the trade-off, and you can certainly imagine selecting viruses for that particular trait.
Andy Weber on the tech that could prevent catastrophic pandemics.
Is there any case for not worrying that much about bioweapons? That they sound pretty bad, but is there anything you can say that maybe makes the picture seem a bit less scary?
Yeah, I'm actually, maybe it doesn't come through, but I'm an optimist by nature, sort of a pragmatic optimist. And I think we can take the whole class of biological weapons off the table. And we're doing work on this at the Council on Strategic Risks. We have a program called Making Bioweapons Obsolete. And, at the end of the day, biological weapons are just infectious disease, right? So you can have a system of early warning, detection, and then rapid medical countermeasures that would give you such good defenses against biological weapons that you could deter your adversaries from pursuing biological weapons because they would realize they wouldn't be effective. Now, we're not there yet, but the science and the tools that are now available can enable this possibility of making bioweapons obsolete. And so we think that's the right vision.
Okay, yeah, fantastic. I'm super curious. Can you maybe just go through some of the technologies that you're most excited about that could potentially make bioweapons obsolete?
Absolutely. So it starts with early warning. So think about some of the revolution in diagnostics and testing that's been happening because of COVID and during the COVID pandemic. So imagine in-home testing. Every morning when you brush your teeth, you breathe into a tube and if you're infected with a virus, and it tells you which one. That's sort of the early detection that's now possible. You might have it hooked up to your smartphone and it would report into a public health surveillance system. And so you would know if it's just an isolated individual or if it's spreading into the community. So that early warning piece. And then sequencing is becoming so cheap and fast that you can, within 24 hours, you can determine if a person has a respiratory illness, for example. You can test through sequencing for 300 different pathogens that cause that, as well as virus X, the unknown, the novel. And those are the sorts of capabilities that we need to have that weather map, that prediction of infectious disease outbreaks that allows us to nip them in the bud.
So I know that sequencing technology has gotten a lot cheaper, and I've heard people talk about, at every hospital or medical facility, you could have one of these little like nanopore sequencers, and then you can take lots of samples and see if you're getting, DNA results or sequence results that you don't recognize, and that would set off alarm bells because it's like, oh, this is something new, we need to look into it. Hold on, how would you do this at home? You're saying you would blow into something at home, and this would be cheap enough, and it would be able to tell all of the viruses that you had going around in your respiratory tract? That's amazing.
Right. So those capabilities that you're talking about, that a hospital laboratory might have today, they're getting smaller, cheaper, easier to use. So it's just a matter of time before they're available for use at home. So using sequences, we can have what I call rapid medical countermeasures, therapeutics and vaccines that are based on the sequence of the pathogen and can be developed and then manufactured quickly. Think sort of nucleic acid 3D printers that could use this digital information, because biology is now digital, and develop and produce these vaccines in a distributed way. So we would, as soon as even a novel or previously unknown pathogen were released, we would, in days or a month at the most, have a countermeasure that we can apply to preventing it. So these are the capabilities, while even 10, 15 years ago may have seemed like science fiction, today they're upon us. But we need to invest in this overall system of defenses.
And I guess a benefit of mRNA vaccines, as I understand it, is that you can very quickly go from the RNA or DNA sequence of the pathogen to, I guess you take that and you do some work on the computer quite quickly, and then you're like, all right, we already have mRNA vaccines. Here's the code that we're going to put in the mRNA vaccine. Here's the code that we're going to put inside these little fat droplets that then is going to cause your own body to produce these proteins that will then inspire the appropriate immune response. And so I guess you can go much faster potentially from discovering a new thing to having a vaccine against it.
Yeah. And linking back to the Soviet biological weapons program, there's a reason the Department of Defense invested in a capability like the mRNA vaccines. It's simple. We knew the Soviet Union had been applying bioengineering to its weapons program. So that meant we couldn't just worry about a list of known pathogens. It meant we had to worry about a created pathogen, perhaps a chimera, a hybrid pathogen that had the worst properties of several viruses combined. So that meant that we might face a total unknown, and so we needed a capability to sequence it, to characterize it, and then develop the countermeasure. And it's exactly that reason that the Defense Department invested in what we call these rapid response or platform technologies.
Yeah, that's fantastic. And if we want to have this ability to quickly disable any new bioweapon, we need to not only be able to invent the vaccine, I guess it sounds like possibly within days, but then also very quickly manufacture a lot of it and then deliver it into arms, on a very, very accelerated timeline.
That's absolutely right. And technology is helping us with that too. You no longer have to build a massive vaccine plant to produce vaccines. Again, think about 3D printers. There's a company, it's called cell-free manufacturing. There's a company I'm aware of that is building something about the size of a glove box that can produce, for example, millions of doses of mRNA vaccine in days. Because as you said, it's actually your body that does the production of the mRNA vaccine. It's just the message to your cells to produce it that you're injecting. And then, for example, there's microneedle patches, vaccine patches, that could be mailed to people, right? So that would make the logistics of vaccinating people much, much easier if you could just apply a patch to your arm. New methods to eliminate the need for cold chain, for low temperature freezers. All of these are technical challenges that we need to work on, but none of them are insurmountable. Compare the investment we're talking about with the costs of this pandemic, and it's a no-brainer. It really is an ounce of prevention. So, we're now using the term the biodefense industrial base in the United States. We need that warm base, but it's multi-use, right? During a non-pandemic time, it can be used to produce all sorts of things, but then it needs to have the agility to shift quickly to snuff out a pandemic before it becomes one.
The political challenge here is that
people have been saying for decades that, we need to stockpile more masks. We need to have more vaccine manufacturing capacity on standby. We need to be doing all of these things to prepare for a pandemic when it arrives. But the challenge then is, how do you get politicians and the public to vote to spend this money, given that, if you haven't had a pandemic lately, it's going to seem like it's being wasted? That the challenge here kind of seems more a political economy question or a public choice question than one of figuring out whether it's sensible to do, because it just so clearly is.
Yeah, the simple fact is it needs to be a priority, and we're not talking about huge numbers. I mean, I think, the United States, if we invested through the Defense Department and Department of Health and Human Services about $20 billion a year in this, which when you think about it, the defense budget is currently $750 billion a year. It's actually a pittance in DoD terms. I think we could solve this problem over about a decade. So it's an investment that is worth making for our defense, but also for our health. Imagine a world where you don't get colds. I mean, that's what we're talking about too. So it would improve day-to-day lives of people, and that's the beauty of this. It's a win-win-win investment. It's an investment we can't afford not to make. It's cheap, but we haven't done it. What it comes down to is we need to change the definition, to broaden the definition of national security and defense. It's not just about kinetic warfare. It's much broader than that. And keeping the American people and our allies and partners around the world safe from infectious disease is part of that.
Christian Ruhl on why we need the equivalence of seatbelts and airbags to prevent nuclear war from threatening civilization.
So my impression is that most of the work in the nuclear space is on non-proliferation and nuclear disarmament and deterrence. So mostly things that aim to reduce the odds that a nuclear war ever starts. But you're particularly interested in nuclear-related interventions that are helpful in scenarios where nuclear bombs have already been detonated. So you call these right-of-boom interventions. Can you explain the distinction between right-of-boom interventions and left-of-boom ones?
Yeah, so the big motivation here is sort of what is the high impact thing to do here. And I understand that high impact is a very unfortunate phrase to use when we're talking about bombs going off. But I'm going to make an analogy to car crashes. So for car crashes, we can maybe think about dividing interventions into left of crash and right of crash interventions, where left of crash includes things like rules of the road, stop signs, traffic lights, driver's licenses, and so on. And we also have right of crash interventions in case that the first layer of defense fails. So we're talking seatbelts, airbags, features of a car just to make it safer, ambulances, hospitals. Why do we have this? Because we know that there are many reasons that cars crash and accidents happen. And so we can take that back to nuclear war. We really, really want to make sure that nuclear war never breaks out. But we also know from all of the examples of the Cold War, all of these close calls, that it very well could, as long as there are nuclear weapons in the world. So if it does, we want to have some kind of ways of preventing that from turning into a civilization-threatening cataclysmic kind of war that so if you've thought about in your own work. And those kinds of interventions, war limitation, intra-war escalation management, civil defense, those are kind of the seatbelts and airbags of the nuclear world. So to kind of borrow a phrase from one of my colleagues, right of boom is sort of a class of interventions for when shit hits the fan. Basically, the logic here is we should have a layered defense against catastrophic risks. So like imagine you live in a world, again, with cars, but no seatbelts, no airbags, or any other safety features. That's the world we live in right now when it comes to nuclear war. And like fundamentally, that's why I think we should be dedicating more resources to right of boom interventions. So like we know a few things about nuclear war. First of all, not all nuclear wars are created equal. It's like there's a qualitative difference between a single weapon going off and the superpowers unleashing their full arsenals. So one of those is, as you said, there's truly horrific humanitarian disaster, but it's mostly local. And the other one is this unprecedented global cataclysm that might well threaten modern civilization itself. The largest nuclear wars are disproportionately worse than smaller nuclear wars, which means that so much of the total expected cost there lies with those largest wars. It's a familiar feature in catastrophic risk. I think we see something very similar when looking at pandemics and biosecurity. So that's a general idea. But there's also a subtler argument about philanthropic strategy here and about making allocations in philanthropy under high uncertainty. And so like fundamentally, this is about like taking not just one step back, but like 10 steps back and thinking about the structure of the problem at a really high level to kind of figure out the most effective ways to do good at the margins.
Okay, so another one of these right of boom interventions you think is promising is civil defense. What does that mean? What does it look like?
Right. So like think back to like March 2020 and like the confusion and fear that many of us felt about COVID, sort of not knowing how do I kind of keep myself and my family safe, right? So imagine instead of that, we had learned in school, hey, we know these outbreaks happen. So if something like this happens, here are some measures that can help. And imagine kind of the government had kind of taken steps to research pandemic-proof PPE, send kind of high-quality respirators to every household just in case, not that much money, and sort of protecting the civilian population in case of a war or in case of a different catastrophe. So if that's what we're talking about when we talk about civil defense, today it's often called emergency management. So like with nuclear war, we're talking about measures like shelters, evacuation, public education, what do you do? PPE again, stockpiles of critical supplies, food. It was always a topic that came up in the Cold War, but it never really got off. But it's mostly for political reasons, not because it wouldn't have worked.
Yep, that makes sense. It does seem like we did more of that in the Cold War. And yeah, I feel like there's this cultural meme of like duck and cover.
Right.
And it's kind of funny that we don't do that, even though it sounds like at least some of it would be reasonable to do. According to some people, we like face similarly scary nuclear threats today relative to the ones we were facing then. Arguably, that's not true, but still seems like probably the risks are high enough that we should be doing something there if something there would work.
And we have some evidence that sort of some of these measures probably would work. In Nagasaki, there were about 400 people who, very close to ground zero, took shelter inside of these hillside caves. And these 400 people survived. And not only did they survive, except for the people who were sort of immediately by the entrances to the caves, they survived uninjured. So like, we know there are ways to protect people, right? It's really scary to think about, but like it's potentially worth thinking about.
Yeah, moving to another one. We've already touched on this a little bit, but again, we have hotlines and also just specifically war termination. What do those look like?
So one of the things you want to be able to do, again, if a nuclear war breaks out, is make sure you have a way to communicate with the adversary to say, hey, let's stop this, let's find a way to have peace. And unfortunately, as far as I can tell from kind of public sources and from talking to experts about this, the nuclear hotlines we have seem likely to fail in the event of war. And obviously you can't end the war if you can't communicate with the adversary. And so this hotline, implemented, as I said, in 1963, like really early versions were pretty fragile and insecure. There was one kind of funny case where a farmer in Finland like accidentally plowed through a cable in 1965. And then so they've made updates every once in a while. So they switched to satellite in 1971, added fax in 1984, and switched to email in 2008. But sort of one of the last public examinations we have about hotline resilience is from the 90s. And they write, quote, "The DCL is not designed to survive or function in a war environment. Its principal component subsystems are essentially unprotected against blast or other nuclear effects or electronic countermeasures, such as jamming." So again, like a huge problem. Seems like obvious that we should try to fix it. I think like a study group in the public to say, like we don't have access to the classified information about what these systems actually look like, but we want to make sure this will actually work.
Yeah, I feel pretty shocked. I did not know that the hotlines would fail after a nuclear blast. That's insane. And when I imagine, like, it feels hard enough for leaders trying to de-escalate a nuclear war to do that with verbal communication and without, when you're just guessing about what another country is thinking, that just feels impossible. So that's absolutely horrifying.
Like, what are you gonna do? Like, explode bombs and like Morse code or something? I don't know, right?
That's bizarre. Yeah, truly bizarre. Do we just like have technology that would survive nuclear detonations, and like we could just in theory implement that but haven't, or do we have to develop something somehow that's more robust?
Yeah, so I think it's really complicated, and a lot of like the stuff about this I do think is probably classified, so it's totally possible, right, that I'm wrong about a lot of this. But we know that nuclear weapon states care a lot about the communications links of their own systems. So the NC2, making sure that keeps working if a war breaks out. It's kind of this perennial focus of war planning, is sort of ensuring the resiliency of NC2 systems. And it would seem like kind of the very same care and sort of whatever measures are taken to, say, protect electronics from EMP, stuff like that, might very well be used kind of for state-to-state communications, or maybe you sort of make it redundant with multiple satellites in case there's like war in space, right? I think there are many things we can think of. Again, totally possible that I'm just like wrong about this, but from what we can tell publicly, like it would fail. So I think one of the things that people don't appreciate is that even if nuclear war breaks out, and even if humanity survives, and even if civilization recovers, that recovery might not be with good values. So you can imagine things like unconstrained competition around AI between like multiple authoritarian states after a nuclear war over Taiwan. We might worry about the risk of locking in certain kinds of political systems, and about totalitarian political systems perhaps being more likely to survive.
Sure. And just for context, the reason we might worry about this is because, for various reasons, AI might make it possible to kind of lock in political systems or value systems by kind of stopping different modes of cultural evolution. For example, by enabling identical digital copies of totalitarian leaders so that there never has to be a regime change, just for one example.
So let's think about like concrete levers we can actually affect what kinds of political systems might survive after nuclear war. So like one of these in the US is the continuity of government plans, or COG plans. So there's like Raven Rock designated survivor kind of stuff, making sure that sort of US government continues in some form even if there's sort of a nuclear war. But if you look back and look at what some of the Cold War plans were for what to do, there's a great book called Raven Rock actually that talks about this. But let's take the Eisenhower administration as an example. As I understand it, the plans were sort of completely insane and like authoritarian. He had set up this system to, where in a time of crisis, a small handful of his best friends who would take power, nationalize industries, restructure the government, and basically start this crazy oligarchy. Now, COG plans are obviously sort of very classified. That doesn't mean that philanthropists can't have an impact here. So one thing you could do is kind of fund a high-level study group, like continuity of government against emerging threats, include nuclear war, include biosecurity, include AI, and sort of do policy advocacy of key decision makers that ultimately make these plans, and emphasize the importance of having mechanisms to return to constitutional democratic government, sort of to keep the kind of values that we care about. And there's actually an example of this in 2002, a right-leaning think tank AEI and a left-leaning think tank Brookings worked together to do this continuity of government commission. So there's like precedent for doing something like this. Again, like I think there are really concrete things we can do to make sure that if God forbid something like this happens, things go a little bit better than they otherwise would.
Mark Lynas on whether wide-scale famine would lead to civilizational collapse.
Let's maybe talk about the famine channel first. I'm worried about that, but I think a bit less worried than you. I guess there's two ways or two things that we could maybe look at. One is what's the probability that we have a really big food shortfall? And then what's the probability that that leads to some kind of cascading civilizational collapse? Let's maybe do the second one first. So imagine that we do have a whole bunch of breadbasket areas that all have kind of a drought simultaneously. And so food output globally goes down a bunch. Let's say we only have, 80, 70% as much food as we have in a normal year. What's the path by which that leads not only to like a lot of people dying of hunger, but it also leads to, civilization as a whole falling apart?
It's reflected in prices. So, obviously that the price mechanism is the rationing mechanism that we have to decide who gets to eat and who doesn't in pretty much every society. And there was some forewarning of this in the 2008 food price spikes, which are more related to the oil price at that time, actually, than any scarcity of food. But I think the same thing would happen. And even then, the food producing countries cease to export. And so they put on export bans, which then affects the commodities trade. It means that food importing countries experience both rapidly increasing prices, and the result is food insecurity. So if prices double, triple, you get more than a 30% reduction, by the way. If you lost that much harvest, you'd be down to, you'd lose all of your world food trade. So food importing countries would potentially starve very quickly. And so I think, and people aren't just going to sit there, and gradually get hungrier and hungrier. They're going to move. They're going to, move in their millions to try and find whatever food's available anywhere. And those kinds of dynamic effects, I think, both very difficult to predict, but
don't look good.
No, they don't. Exactly. No, they don't look good. They're not going to have an outcome which means that everything's hunky dory.
So maybe people moving around in order to find places where they can eat might lead to refugees, and that would possibly lead to conflict. But also, is that the idea in terms of, and then that would lead to collapse?
I guess. It's again very difficult to predict the response of countries which do still have food sufficiency. Are they going to be prepared to share, or are they going to put up borders, build walls? The evidence from the Syrian refugee crisis suggests that the response will be to close borders and build walls and allow people to drown in the Mediterranean in their hundreds, as Europe has done. And, look at the political ramifications of that. You then saw a rise in populist movements and almost fascist type political parties, which are now in power in several European countries, and take us back to a time which is scarier than any since the 1930s, I would say. And this is Syria. This is one country. Imagine this happening across a majority of the world's countries. Then those countries which do produce enough for themselves are really going to have a tough time. So, yeah, I think we can take glimpses of the future, perhaps, from some of the really awful things that have happened in previous years, but the sort of multi-systemic nature of it doesn't really give you a sense of the magnitude of the result, I don't think.
So when I envisage a situation where there's a huge food shortfall like that, well, firstly, I think we'll probably have some heads up that this is coming ahead of time. You start to notice the warning signs earlier, like food prices going up and food futures going up. And then I kind of imagine that people would start, because this would just be like, it'll be an emergency, a global emergency on the same, like much worse than the coronavirus, say. You just start seeing everyone starts paying attention to how the hell can we get more calories produced. And fortunately, unlike in 500 years ago, we are in the fortunate situation where most people today aren't already producing food, and most capital today isn't already allocated towards producing more food. So there's potentially a bunch of elasticity there where if food prices go up tenfold, that a lot more people can go out and try to grow food one way or another, and a lot more capital can be reallocated towards agriculture in order to try to ameliorate the effects. And you can also imagine, just as like everyone in March was trying to figure out how the hell do we solve this COVID problem, everyone's going to be thinking, how can I store food? How can I avoid consuming food? How can we avoid wasting food so that every calorie looks precious? And maybe that kind of sense of our adaptability or our ability to as a globe to set our mind to something when there's a huge disaster and just throw everything at it, perhaps makes me more optimistic that we'd be able to muddle through, perhaps more than you're envisaging. Do you have a reaction to that?
My reaction is, imagine if Donald Trump is in charge of the response. It's all very well to have sort of optimistic notions of technological progress and adaptive capacity and things. And yeah, if smart people were running the show, that would no doubt be the most likely outcome. But smart people don't run the show most of the time in most places, and people are amenable to to hate and fear and denial and conspiracism and all of those kinds of things, as you've seen even in the very short-term challenge of COVID.
Yeah, it is interesting. I'm not sure whether to update positively or negatively on society's resilience watching COVID. I mean, there's some places that have handled it, really admirably well, and we've been impressed by how good their governments are, and then other places where it's just been remarkably incompetent. But something that's really struck me is how disruptive it's been to have a virus that has an under 1% fatality rate, which you'd think, like, in the scheme of pandemics, really isn't that serious, and yet it's just like it threw everything into disarray pretty quickly, which has maybe made me more worried about these kind of flow-through effects, and being like, well, if 10% of people are starving, like how much disruption does that create to everything? And I guess the fear of conflict, like how much does that make it hard to get anything done?
Well, and it wouldn't just be a global average of 10%, like you have a global average of 1% for COVID. It would be, 50, 90% in certain places. And I think that would be a psychological shock to us as much as anything. Even if you're in a country which is likely to survive, just seeing that extent of famine, would be in a, as you say, we haven't seen anything like that since the medieval times. But yes, society's tolerated with the Black Death, the loss of half of the population across much of Western Europe at certain times. And there were famines which probably had death tolls which were of similar magnitude in those times as well. And what did people do? They worshipped, they castigated themselves, they fought wars, but they survived. So that is necessarily the sort of herald of extinction. But remember, these processes are getting worse unless we've stopped emissions by that time, because the economy just can't. How are you going to carry on burning huge amounts of coal or any kind of fossil fuel if society is so challenged by a mass famine, for example?
I was, reading your book, and you mentioned that one issue with talking about adaptability is that it's going to be much harder to adapt without burning fossil fuels if we haven't already transitioned into like a carbon-free economy. So fossil fuels are the source of our ability to do so much. So maybe people will feel like, okay, well, we really need to just, for the next 5 years, we really need to do this huge project in order to adapt, which is going to require us to use a lot of energy, which is going to require us to burn a lot of carbon, which might make it so that people are more likely than I had initially sort of intuitively thought to continue releasing carbon into the atmosphere, even as things get really, really bad.
Well, that's the kind of Dubai scenario where you have a sort of an oil-dependent, a petrostate under a huge air-conditioned dome in an intolerably hot environment, which is entirely dependent on artificial water, artificial energy generally, and food from elsewhere. So yes, it's certainly possible that whole cities can exist in an ambient environment which is intolerably hot, but you can't do that over an entire subcontinent. You can't build that dome. And the process of, you can see this process already happening with just with air conditioning. So air conditioning demand is one of the biggest drivers of increased energy use and increased coal burning in India, for example, and other places too. So maybe that's a kind of feedback, a smaller scale version of the feedback you're talking about.
Yeah, it's interesting. It'd be like a human feedback loop or something.
I think one part of what Arden's is gesturing at is that if in 50 years' time people see that the world is on fire or things are going horribly because of climate change, some people have the intuition that, won't that cause us to stop burning fossil fuels? Because we'll have seen by that point how reckless it is to do so. But I think that kind of underestimates human stupidity. I'm not very calmed down by that, because kind of the international public good problem will still be there. The fact that the incremental emissions that you do at that point in order to deal with that situation, that's going to cause problems more in the future than it does right away. I could totally imagine a situation where the world is falling apart and people maybe even want to burn fossil fuels even more because they feel desperate to find some way to cope with the situation, and that just makes it worse.
Or they're like, it's already so bad, we might, or there's some sort of defeatism.
What the hell
could happen?
Let's return to this famine issue. So it sounded like you thought that in some of these 3 or 4 degree warming scenarios, we could end up with food production halved or more in a given year, which is perhaps more than a bigger impact than I expected. Yeah, maybe try to convince me of that's how big the effect could be.
Well, you just need to look at the scale of the issue. In terms of food production, it's only a few hundred millions of tons which make up the food trade, which is only a few percentage points really of the overall production. So you don't have to lose very much to eliminate all of the traded commodities of rice and corn and wheat and things that now constitute a majority of the calories for importing countries. So you've got this, it's Ricardo, isn't it? Going back to classical economics, you've got this sort of specialization where countries which can can produce food do, and then trade it for other things which are produced in countries which have a sort of better capacity to do other things. So, the other thing you've got to think about is to what extent does that drive us into a autarkic sort of production model where everyone closes their borders, you only think about your own population, you ignore famines abroad. There's clearly when politically leaders are responsible to their own populations, that's your main motivator. You don't care whether people are dying in faraway countries. And like I say, that did begin to happen in 2008. The first response was to close borders and to stop exports in order to, both in order to protect the price and to protect supply at home. Because if you're exposed to international markets, then you get increased prices even in a domestic situation where you produce enough food yourself, of course. So that kind of dynamic between globalization and a return of protectionism, I think, would be a huge driver of what actually happened in terms of food security globally.
David Denkenberger on low-cost, low-tech solutions to make sure everyone is fed no matter what.
Certainly a concern here is that our initial modeling is assuming global cooperation, that the UK has a lot of potato seed, they wouldn't be able to grow them themselves. Would they actually trust another country to grow the potatoes and then give them back more food than originally? And so ideally, we could actually talk about some of these agreements ahead of time so that people could be pre-committed to it.
I see.
But certainly, we are concerned about cooperation breaking down. And so we're going to be moving into a more regional geographic information systems or GIS analysis, looking at the resources of individual countries from a resilient food perspective, and then actually working out, what would happen if international trade turned off? It would be much worse. Yeah. And what we're hoping to do is use that information to convince governments to actually cooperate. In the past, like say 2007, 2008, the actual food production shortfall was less than 1%, but it was because countries doing export bans that rice price went up 3 or even 4 times. And so it's a major risk, restriction of trade. And there's even potential of restricting more than just food trade if we lose that trust and cooperation. And that would be just catastrophic, because then you lose energy trade and minerals and components, and the supply chain issues we've seen in COVID are nothing compared to that.
Right. I guess, so we're considering a bunch of different scenarios here. I suppose with volcano, probably almost no infrastructure is destroyed. All the ships are still running. In the nuclear war case, a whole bunch of stuff is destroyed, but still a remarkable fraction is still online. I guess you have to kind of model these quite differently if you're trying to figure out, what is the threat to international cooperation in each instance.
Well, I think in the case of a supervolcanic eruption, you could certainly have continent-scale destruction of infrastructure.
Oh, interesting.
Similar with an asteroid impact. Yeah. A similar order of magnitude, I would say. However, there are important differences. One reason why nuclear winter is significantly worse is because it's black particles going into the stratosphere, and those absorb the sun, and then they're lifted higher, so they can stay for a decade.
Right.
Whereas the volcanic, it's sulfate, more whiter particles, and they fall out faster.
I see.
But then also there's if you have a nuclear war, there's
someone's been annoyed with someone else. There might be some pre-existing tension.
Yeah. Of course, it could be accidental, but still there's an enemy involved. And so cooperation would be even more challenging.
Okay, yeah. Do you have an intuition for if there was a supervolcano eruption, whether humanity would mostly pull together? My sense was cooperation during COVID-19 was pretty good, and it could be even better during a volcano situation.
Potentially. I mean, I'm very concerned that if people don't know about resilient foods and then they conclude that most people are going to die, well, it could be in the incentive of countries to do very bad things like steal food from your neighboring countries. And so I am very worried about that. And that's why I want to get the message out that we could actually feed one if we cooperate. One of the things we've done is look at the current costs of these resilient food production, because many of them are already in production. And that gives us some idea of how cost effective they might be, though, of course, the actual catastrophe could change things. And in the catastrophe, it might not be so much that it is dollars that we're talking about, but it's, how many resources go into it. And I think that's correlated now with the current price. And so that allows us to prioritize. And one of the technologies that came out as promising is this turning fiber or wood or cellulose into sugar. And so we looked at constructing factories to produce this sugar very quickly. But what looks to be more promising is taking an existing factory that has a lot of the components we need and repurposing that to produce sugar. And one of the most promising we found was a paper factory, because it already takes wood and it takes a lot of energy to grind it up and do that pre-processing step.
Yeah.
And then it's not that much more work to break the cellulose into edible sugars.
Huh. Okay, so basically, should there be a nuclear winter or terrible volcano or something like that, we'd still have a whole lot of wood and other plant matter that is just out there in nature. And there's a lot of energy embedded in that. But the problem is humans cannot eat wood. And so we need to find some way to make it digestible. And you're saying it's possible to turn it into the kind of sugar that we would normally eat? Like it's possible to break it down into glucose and then we can eat that?
That's right. And there are actually a couple startup companies that are trying to turn fiber into edible sugar.
Huh.
Now, that's great because they're doing some of this research, but they're just not thinking, how would we do it fast in a catastrophe? And so that's the type of research that we're looking at.
So, yeah, what's the process for taking a bunch of wood and then turning it into something that people can eat?
So basically a lot of grinding in the beginning, break it up into pieces, and then you apply something that, we call it lignocellulosic material. And that comes from the cellulose, which is basically lots of sugar molecules stuck together. There's also hemicellulose, which is similar. And then there's lignin, which you can't really do anything with the lignin. So you need to separate those components. And then you apply an enzyme to break the cellulose into sugar and the hemicellulose into other sugars.
Okay. Is this with a bacteria or do you use like chemicals to break it down?
It's typically done where you'll purify an enzyme that is produced by an organism like a fungus or bacteria, but then it's done without that organism in a bioreactor.
Okay. So I guess fungus eats logs. And I guess there's probably bacteria that eat logs as well. And I suppose they also probably can't directly absorb cellulose or anything like that. So they themselves have to break it down into sugar somehow, right? And if I remember from my biology classes, kind of fungus extrudes some sort of acids or other compounds that break down wood into something that then the fungus can absorb and use to get energy. And kind of are we to some degree like mimicking that process to make something that humans can also eat?
Exactly. And so we could, as we mentioned, mushrooms are one way of turning wood into food, but it turns out they're pretty inefficient. And so if we can just grab the enzymes from them and then turn all that cellulose into sugar, or nearly all, we get a lot more food out of it than with the natural process.
That makes a ton of sense. How expensive would this be? I mean, is this a way that we could plausibly make food at an affordable price today?
Yeah, amazingly inexpensive. Even though we'd be doing this repurposing with 24/7 labor, we would have to pay more for that. And even considering the fact that we wouldn't run these factories as long, we probably only be running them for 10 years during the catastrophe, that increases the cost, but not that much. And so we got around, if you were to feed one person all of their calories, which obviously they wouldn't eat all their calories, but it's a way of visualizing it, it's only about $1 a day from cellulosic sugar. And that's our target here, because we're trying to feed everyone no matter what.
Yeah.
We want to look at those resilient foods that are inexpensive.
Makes sense. Okay, yeah, what else can you give us an update on?
Well, given that we might be able to, actually have some sunlight here, one thing that we didn't get to investigate in the book, but now have since, is seaweed production. And we found that it's very promising. There are several species of seaweed that even with the lower light levels in nuclear winter and lower temperatures can still grow 10% per day.
Even up to like adulthood? Or they just keep going at 10% a day?
They just keep growing. So basically you have these long lines that are floated by these buoys.
Yeah.
And you start with little pieces of seaweed and they grow, and then you just chop off the growth and then they just keep growing. It is amazing. And it's only certain species. And right now they're often limited by nutrients. And so at least in the near term, we would still have those nutrients. And then I talked last time about the potential overturning of the ocean, that if you cool the upper layers of the ocean, they sink and bring up nutrients. So it turns out that is not as large as I thought it was going to be. So the actual production from fish is not going to go up as much as I thought. But with seaweed, it's just much more efficient growing it directly than having algae grow and then feeding it to fish.
Right. You skip a trophic level, or you don't need an extra trophic level. So
right.
So the point there is that during a nuclear winter, say, if agriculture is interfered with, the atmosphere is colder, that cools the upper layer of the sea, and then that tends to sink down, which then creates this kind of upwelling of nutrients that are on the ocean bed. And then that basically provides fertilizer to seaweed to grow faster than it would normally. And so potentially you can get seaweed growing even faster than it was before.
Yeah, potentially. I think what they've found is that what they call the net primary productivity, that is how much biomass is produced per year, will still fall in a nuclear winter, but it won't fall as much as on land because of that nutrient enrichment.
I guess there's also one benefit that anything under the ocean has is that the temperature falls much less under the sea because the water kind of buffers the temperature change. And so while you might get a lot of plants on the surface dying from frost and things like that because of the winter conditions, under the ocean, like the temperature might only drop a couple of degrees. That's right. Yeah. What kind of inputs do we need in order to grow much more seaweed? I guess so you got to be around a coast. And then you were saying to grow seaweed, you kind of attach it to ropes? It's a bit like kind of rope-grown mussels or something like that.
Yes. So it turns out we produce a lot of synthetic fiber for other reasons, like clothing. The main constraint here is twisting those fibers into ropes that we're going to attach the seaweed to. And we found that right now we don't produce that much rope. We would actually have to increase our rope twisting capability by 300 times.
Okay.
Which sounds kind of crazy, but it's actually a really simple process. And people have done it in their garage with a drill, basically twisting these fibers. But these pieces of equipment are only like $10,000 and you can make a lot of rope. So it turns out it takes a very small percent of our manufacturing budget to make a lot of rope twisters.
So, I mean, most seaweed is growing out of the ocean bed on rocks and things like that, right? It attaches to something on the bottom and then it kind of grows upwards. But that's no good for us? Or I guess all of that seaweed that can attach to rocks on the bottom of a coast, that's already growing. So we need to have some artificial environment that's very conducive to seaweed growing. And I suppose the closer it is to the surface, the more light it's getting. So it might grow faster if we are attaching it to ropes near the top.
That's right. And so seaweed, why it can handle low light levels is it often does grow 10 meters down in the ocean. But yeah, we want to have it near the surface in nuclear winter.
Athena Aktipis on whether society would go all Mad Max in the apocalypse.
As you said in the intro, your next book, Everything is Fine, How to Thrive in the Apocalypse, is about how we think about civilizational disaster scenarios and the effect that thinking about that has on us. What's something that people worry about in the apocalypse or in a catastrophe that maybe they shouldn't worry about quite as much as they do?
Well, the big one for me is this idea that as soon as something starts going wrong, that the fabric of society is going to fall apart and that everyone will just be like every person for themselves. Because if we look at, what actually happens during times of disaster, people jump into action to help each other, in this sort of need-based way, even helping strangers, even, going to extreme risks yourself to rescue people. People just do this spontaneously when the shit hits the fan. And yes, if disasters go on for a really long time, if you have, slow burn situations where people are starving and that lasts for, months,
siege warfare,
or years, right? Yeah. Then when people are in a state where they just literally don't have enough food or water or whatever, our physiology starts to not function normally. And, things can break down once you get into that famine territory. But if we're just talking about sort of acute disasters, and if we're talking about situations where ultimately people are able to jump in and help each other and, and deal with fixing some of the problems that have arisen together, you see that in the first few weeks, especially after a disaster, before everyone kind of now we're going to kind of go back to normal. So I think that people having the wrong assumptions about what happens in those moments, not only is that not supported by what we see in times of disaster, I think it can also be really problematic.
It was a destructive attitude.
Yeah. Yes. Yeah. And it doesn't necessarily put us in a good place to be proactively managing risk together either, right? If you're everybody's going to turn on everyone.
Everyone for themselves. I got to get my knife. Yeah.
Yeah. The sort of survivor mentality,
Mad
right?
Max.
With that show, right? In the end, it's everybody's pitted against everyone else, even if they cooperate a little bit, often that's not how it works. Usually that's not how it works. We humans survive because we, cooperate and work together. And that is how we have survived.
How we got here.
Forever. Yeah. Yeah. Hunter-gatherers, like, you don't just have one like hunter-gatherer, like foraging and hunting. Like, they live in a group and like they share, at a central place, usually around a fire, right? Like with whoever's gotten what. Like that's how
It's how our organism operates, basically.
Yeah. And we like it. Like we like to eat.
A single hunter-gatherer is a dead hunter-gatherer.
Yeah. And I think like a lot of that's reflected in just how we're set up psychologically and emotionally, right? We like eating with people, like a dinner party is super fun, or like preparing food with people, or, just spending time with others, creating things together, or, like we really thrive on being social and taking care of others to a certain extent too, right? That's it's something that a lot of people intrinsically enjoy. And so I think really delving into that side of, our human nature that desires to be interdependent and embedded and generous and helping others and, part of systems that are functioning well, where, we're there to back each other up and manage risk together. I think, we like that stuff. And the better we can understand the sort of evolutionary mechanisms and, cognitive and emotional mechanisms that underlie that, the better a job we will be able to do to manage the risk of the multitude of apocalypses that we're likely to be facing in the future.
Things can go wrong. Yeah, it's been interesting watching the conventional wisdom on this shift over the last few years. I think back in 2019, the conventional wisdom, or like people's intuitions were really that even quite modest disasters would lead to the breakdown of law and order. Yeah, everyone's just like stealing from one another just because it's some relatively mild problem. And then I remember early on in COVID-19, some people were predicting, there's going to be like blood on the streets. It's going to be chaos. Everyone is just going to look out for themselves. There'll be a crime wave. And the exact reverse was the truth. Crime went way down. Violence went way down. I mean, to start with, if people are staying home, it's much harder to get into fights. It's much harder to burglarize their house when there's people in there.
Yeah.
I think actually the US is almost the only country in the world where crime didn't go down all that much. I think there was some kind of unique US-specific factors there, although I think it did go down in the short term. But yeah, now there's been quite a big correction. And I keep hearing this point that people make that it's remarkable how extraordinarily cooperative humans are when things go wrong. Like when everyone's part of the same struggle, the same, they're fighting against adversity together, then actually we're way more cooperative in that situation than we are just on a typical day.
Yeah.
When we're on our commute to work normally. I wonder, is it possible that we've overcorrected in some way? Is there anything to be said for the idea that people can be uncooperative, or is there any way to temper that?
I mean, absolutely. It's a matter of sort of understanding in what ranges of parameters you get what behavior, right? So in situations where things are bad for a long time and people are starving, then you can get, what we would consider the breakdown of like society and families and all of that. Because, people are literally just on the brink of dying.
It's quite zero sum.
Yeah. And also, I think we don't really know, like when you get to the point of people being in that sort of starvation state where they're very likely to die, like what of the behavior that you see would we call adaptive from an evolutionary perspective, i.e. was selected because it provided an advantage versus a byproduct. So it's just like, this is a very unusual state for the organism to be in. And there are things that are happening that are just the result of molecular pathways that are, So we don't know. And, it's not something that we can really study, obviously. So I think, but practically what we see is in those situations that you do get a breakdown. And, the other situation where you definitely can have favoring of cheating is in, groups where there's a bunch of anonymity, they're large, people don't necessarily feel like they have a stake in the well-being of the group that they're a part of.
There's not kind of peer monitoring or perhaps, justice done when injustices are committed.
Yeah. And so, in those kinds of situations, individuals that are exploiting are going to do better. And if people see that exploitation and cheating is happening, then that can very quickly unravel, if the sort of norms start changing about that. So I think, we absolutely need to consider both sides of the coin here. You know, what are the situations where cooperation is not just makes evolutionary sense, but also is like, you know, how people behave in practice. And then where are the situations where, you know, exploitation and cheating really are problems, both from an evolutionary perspective and a practical perspective.
Luisa Rodriguez, and why she's optimistic survivors wouldn't turn on one another.
The typical story is more like people are at one another's throats or killing one another. It's like zombie apocalypse almost, where it's like the last person surviving like gets all the food supplies. Yeah, what reasons do we really have to think that people would strive to get along and find one another?
Yeah, I guess I do feel a bit peace and lovey when I talk about this, but it does just, I think you even pointed me to the research on how people react to crises. And it's like, according to like sociologists who have looked into post-crisis response. And again, this is hard to generalize from because it's not actually a case where maybe the world's going to end. It's like sociologists looking at how individuals and groups respond to like tsunamis and hurricanes. And it's just almost unanimously not violent. Like looting is a kind of like famous trope, but almost never happens. Same with people fighting over resources. I think it's like, it did feel intuitive to me that there'd be like lots of violence because people would be facing death. But not only does that not look like the case empirically, it also just doesn't look like it looks like a strategy that might help some individuals survive if you just think about it theoretically. But it really doesn't seem like a strategy that would be good for the majority of people to take on, because most people will really benefit from cooperation that lets them grow more food. Like an individual will have a very hard time producing enough food for themselves. And like there's a reason that we live in cities. It's because we specialize and like produce more stuff for the number of people. And so cooperation has these like clear benefits, especially in the context of agriculture. And insofar as like there will be some selection for like survival strategies, it seems like lots of people would benefit from taking this cooperation-y strategy. And that there will be like some cheaters or people who use violence to get a bunch of resources. But on the whole, that's not going to be a very persistent survival strategy.
Yeah.
Because you've got to have someone to steal from.
Right. Yeah, that's true. Yeah. Are there other like case studies that we can point to where people cooperated to a surprising extent?
So both Hiroshima and Nagasaki suffered, just horribly. I don't think I fully understood before looking into the details, but basically a third of the population died. I think the population started around 400,000. And I think maybe a quarter of those people died instantly. And then another set of tens of thousands of people died from kind of radiation poisoning in the weeks after. So that already was horrible, of course, and shocking to learn, and especially to learn about the details. And then, I just remember being really surprised that 90% of the city's buildings were either totally incinerated or reduced to rubble. So just like this huge infrastructure loss. And then at the same time, I also learned that the recovery was just shockingly quick. So if you think, the analogy doesn't totally work, but if you kind of imagine these as cities whose kind of societies basically collapsed, how quickly they were able to recover is just really astounding to me. So I think power was restored to at least homes that weren't completely destroyed within, I think it was like a month or so. Water pumps were restored within, it was just a few days. Actually, maybe what surprised me even more was some intermediate services were back within the next 2 or 3 days. So they had trains running. Yeah, trains running on like day 2. I remember learning that there was a bank where I think, God, this is awful. I think literally all of the employees were killed immediately, but the bank was able to reopen a few days later. And those services were actually just really important to getting things up and running again. Other things too, like telecommunications. So they had phones back, I think on day 2 or 3. And all of this was...
beggars belief. You've checked the sources on this? It's like...
I think the thing that makes it less generalizable is obviously the fact that they just had tremendous support from very nearby cities. And those volunteers would have come in and like literally hauled, in some cases, new like pieces of equipment.
Another interesting kind of historical analogy that like doesn't quite fit but speaks to the fact that people don't turn on one another that much is mass aerial bombing in World War II. There was this big theory in the military in 30s and 40s that if you bombed a city a lot, like London, like Dresden, like Tokyo, that people would lose their morale and they would like lose the will to fight the war, and it would cause the other country to surrender. Nothing could be further from the truth. It had like no effect like that. Like, do we remember the Blitz in London as the time that people like lost interest in fighting the Nazis? We do not. And nor is that the case in any of the other countries that were bombed. Like, they pulled together and they felt like extremely angry with the people who were fighting them. And in fact, like they coordinated more than ever in order to like overcome this adversity. And something that's unique about that case, I guess, is, well, something that's different about that case is that you're specifically fighting an enemy, an external enemy. But we saw some of that with the pandemic, and like in the war cases, which is some of the most destructive, then you would have this thing. You could imagine in the post-nuclear apocalypse thing that people would feel like an enormous sense of camaraderie with their fellow citizens who have suffered this immense
we are all
catastrophe.
Suffering because of the same thing, whether it's a nameable entity or like another state or a pandemic. And the other thing I have about this is even if you get some groups where, for whatever random reason, there happens to be more violent people or something, and you actually do get some like set of factors that means there's violence, they're just, I guess this only applies if you have isolated groups, at least somewhat isolated groups. But like, it doesn't really make sense to think of it as a single, I don't know, pool of survivors. If it's many survivors, there'll be kind of geographic variation in like what culture is like, just like there is now. If there are a few survivors, they'll probably be in like groups that actually don't contact each other that much because they're like, one's trapped on Australia. I mean, maybe not trapped, but they've settled in different places and they're not really exchanging much. And then like, you have to think it's a really dominant outcome is that none of these groups will end up being cooperative. And I guess, I mean, you could have that view. It's a really dark view. You have to believe that human nature is just really, but it just does not seem strategically robust.
Even historically, when you have like a very aggressive group that tries to attack another one, they don't almost ever try to like exterminate the group that they're conquering. They want to tax them almost always. And so it's like, even if you're a marauding group in the like post-nuclear war world, what you want to do is get people into your control so they farm, and then you like tax some of the agricultural like surplus that they're producing ideally. The scenario where descent into conflict and just total strife and lack of coordination like potentially makes sense is one in which there are no productive opportunities, where there's no ability to farm or make food or really do anything.
But then you're dead anyways.
Yes. Then probably you're somewhat dead, I guess. So certainly in the case where the infrastructure isn't destroyed and you don't have like massive, like a sufficient climate disturbance that agriculture becomes impossible. In fact, people will see like productive opportunities all around them to scavenge things, to try to grow things, to like to move to a place where you can grow things, to like even in places where it's incredibly cold and you can't grow wheat or whatever, you can still do fishing.
Grow potatoes.
Right? Grow potatoes.
Or if not fishing.
Okay. So I think that might be like where the folk sense of we would just descend into Mad Max comes from, is the idea that there's nothing that you can make. But I think that is empirically unlikely.
That makes sense to me.
Yeah.
David Denkenberger on how resilient foods research overlaps with space technologies.
Is there any potential to use, space industry's need to feed people in space as kind of a stepping stone for funding research and development into these different methods that then could be used for these resilient foods on Earth? Or is space industry just so small that this wouldn't be like a big enough industry to really like bootstrap any of these approaches?
I think there's potential overlap. It is at a quite different scale. I would say that, one potential overlap with global catastrophic risks would be the really extreme scenarios where potentially everyone has been killed. That you could think of, well, can we make a refuge with 1,000 people that might be able to repopulate the Earth? And Elon Musk is interested in doing this on Mars. So if we could figure out how to make an independent colony on Mars with fewer people, with less expensive, less infrastructure intensive food production, then I think that could have some existential risk benefits.
Yeah. I guess there's another option is doing that, but somewhere really remote on Earth, like, under the sea or in Antarctica or so on, where you'd also have to figure out how to feed people in worst case scenario. And there, I guess, it sounds like you could potentially use a nuclear reactor to grow bacteria and then eat them, or otherwise just have stores of fossil fuels, or put it somewhere where you have access to fossil fuels, and then you could in theory eat that.
Yeah, that's right. So again, if you look at the plans for having an underground bunker, typically nuclear, but the plans were to go through regular plants, and that's really inefficient. So we could lower the cost of this significantly.
So either you have this enormous initial cost of stockpiling all of the food and making it big enough to store food to feed everyone for ages, or you've got this horrifically inefficient process of converting electricity into human edible food that now we can do 10x better on.
Well, and the other thing that if you use the stored food is that you're breathing out carbon dioxide and you need oxygen. Whereas if you have a system that actually grows food, either plants, which is of course inefficient, but these space-based resilient foods, if you want to call them that, they can act as the life support system because they would actually take the carbon dioxide from the astronauts to make the food, and then they produce oxygen. I guess another extreme scenario is a runaway climate change scenario where it might get too hot for plants to live. And so that's another scenario where having these type of, quote, space foods could be a good food source.
Interesting. Yeah, God, could be a very bizarre future, I suppose. Mostly just eating bacteria grown in electricity. Again, it sounds like absolutely bizarre sci-fi stuff. I kind of can't believe that it actually works, but sounds like in principle it could.
Zach Weinersmith on what we'd practically need to do to save a pocket of humanity in space.
Okay, so what's a good argument for why we should scuttle space?
So something we call the cathedral of survival. And the idea is essentially, look, in the very long run, it would be good to have a second reserve of humanity in case something goes drastically wrong on this planet. Now, as I said, I don't buy that as a short-term thing, but there is at least a kind of plausible, well, this is something the humanity should have worked toward in the next 100 years. And we do argue, for reasons we might get to, that it is a project of a great period of time for research and development. Then there's no reason not to put in the first bricks of the cathedral now, even if we'll all be dead when the project is completed.
Mm-hmm. But I guess, you're still not totally convinced it's even realistic. At least, again, not on the timescales that lots of enthusiasts seem to have in mind. Hence the subtitle of the book, which I thought was great. Can we settle space? Should we settle space? And have we really thought this through? And a big reason for that is that it's just really, really, really hard in lots of ways that people, I think, don't appreciate, myself included. First, I guess there's the fact that space is a terrible environment for a human body. Can you talk about why that is?
Almost anywhere in space, the moment you step outside your suit or ship, you die. Not non-trivial, right? And definitely in the places we are likely to go, that is true. And that's just the deal. And so to give it just a quick example of why space is a really fussy place to live. So we talk about this, if you want to have spacesuits. So to me, this is a fascinating detail. So spacesuits are kept at lower pressure than spacecraft. And the reason is it's hard to operate like a balloon inside, right, if it's at full pressure. So we keep it at lower pressure. It just makes it easier to bend and operate the suit. In order to do that, you have to up the oxygen concentration so your lungs can still get enough. And we don't like to do that in the craft because on both sides of the Cold War, there were tragedies related to pure oxygen environments. Most American audiences know Apollo 1, but in the Soviet Union, there was a very similar incident with a trainee named Bondarenko. And so it's a real problem. So if, the joke we have is if you're on your Mars hab and your friend is dying outside the facility, you literally can't go save them.
Right.
Because if you put on your suit without pre-breathing oxygen for a while, you'll just get the bends like a diver surfacing too soon. So you'll just wriggle and die while your friend also dies. And actually the only three guys who've ever died in space were Soviet cosmonauts, Patsayev, Dobrovolsky, and Volkov, who all died due to a valve opening when they were moving toward descent, right? So it's not a little thing. Everything is going to be annoying, and so, but the next thing is radiation. Radiation is real bad. I won't go to the details, but the short version is that in space, you get higher doses of different kinds of radiation than you get down here. And with unknown consequences. Radiation is poorly understood even on Earth. It's even worse understood up there. The data we have mostly comes from space stations, which are still in the Van Allen belts. So they get more radiation than we get down here, but it's still different. We only have a tiny amount of data from the guys who got sent to the moon, and they weren't there for very long. It was like on the order of weeks total. And it's just, we don't know the effects of this stuff, and it's scary. Probably the main practical effect is you're going to have to bury your base under a lot of dirt. No glass domes for you. There's a bunch more detail, but it's in the book if people want. But then the big thing probably is microgravity. So in the International Space Station, you experience free fall, right, as if you're in zero gravity. And reliably, that degrades bones. So we know bones, especially like hip bones you don't use a lot, lose something like 1% of density per month.
That is crazy.
It's crazy. And that's with intense exercise, like 6 days a week on these, like they put you like on a treadmill with a spring to pull you into it. And you still have this loss. Similar effects on muscles. They degrade over time. It's considered very impressive. When you come home, you can walk. And there are other reasons for that. But one weird thing that happens in space is when you lose that gravity, you get a massive upward fluid shift. So you lose like 30% of the volume in your legs. Your face sort of just poofing like a baby. And they actually call it puffy face. It happens. The sort of sinister side of it is it's probably associated with this phenomenon where astronauts tend to come back with worse vision. And in fact, astronauts over 40 are sent up with what are called space anticipation goggles, assuming they'll come back with, and this happens even on short trips.
Huh.
As I recall, it's in our book. I think it's permanent, or at least semi-permanent. And so it's a problem. And what's mostly scary about that, it's not just, you can always get glasses, I guess, but like, it's possible that's actually an early sign of broader nerve damage. So there's equivocal evidence of cognitive negative effects on astronauts. We don't have enough data. A big thing underpinning all this is that we don't have anyone who's gone longer than 437 days. I think the next person down is about a year, and it's only like half a dozen people have gone that long. Most people are much shorter. So we really don't have any kind of really long-term data. By the way, a Mars mission is on the order of 2 to 3 years.
Right.
So we.
So another challenge is that if we're actually going to settle space, we need to make new people in space. You said we can probably have sex in space. Is the hard thing gravity?
Gravity, I'm debating how graphic to get here. So it's funny. So one of the things we did for this book is we read a lot of old books forecasting the future of space. And there's a sort of golden age of talking about sex in space, which is from somewhere like 1960 to 1980. And I think it was the right time. And so like Arthur C. Clarke, I don't remember if we put this in the book, but he had some quote that was like, "Space is about to become more erotic." And you're like, oh God, Arthur. So space is Newtonian. If you're in microgravity, it would be easier on the moon. But so basically that means if someone bumps into somebody else, they both go flying.
Right. Okay.
And so from this period, there were attempts to figure out how to manage that. So we've had two different proposals for what one guy called an unchastity belt, which is a sort of elastic waistband for two. And it's funny when you hear that, you're like, okay. And then you think, but wait. How exactly? And then you're like, maybe I'm just not gonna. And then there's another one called the snuggle tunnel. I forget who proposed that, but it was like basically imagine a large pipe with holes in it for ventilation because CO2 tends to build up near mouths if there's not ventilation.
God. Okay.
And I could go on, but
I would argue that space did not get more erotic.
No, it has not gotten more erotic. The dream of Clarke has died. Earth netting space notoriously kind of smells bad, and and by the way, you change undies like every something like 4 to 7 days, so it's just not the mood lighting is not present. There's not a lot of private space. When I say it probably could happen, basically I'm referring to anecdotal reports from men who said they were up for it. We found two men admitting to space onesomes.
Okay.
So that's what I mean by that.
Yep.
So whether you could actually bring the baby to term, I mean, who knows? So I say, human body is not designed for zero gravity, but it is, you could note, this is kind of goofy. We looked up like, does anyone do headstands while pregnant? And apparently this comes up in yoga, and it's okay. And so, they can, apparently fetuses could do -1 gravity. I mean, they are kind of in a, neutral buoyancy tank. And so maybe it's fine. I'd be more worried about some sort of cellular level process that depends on gravity in some way or another that we're not thinking about.
Yeah.
But it is the case, like, evolution would at least design it so like a woman could like trip and fall and the fetus would be okay. So clearly you can alter the sort of acceleration that's being put on the fetus, to say it in a weird way.
Yeah. At least temporarily, and baby seems fine. Yep. Okay.
Yeah. So that's why I say it seems plausible that the baby might be able to come to term unless something we don't know is happening.
Yep.
There are also like little other off ramps. So the environment in a space station is the atmosphere is very different from what we get on Earth. So they tolerate a much higher level of CO2 because they have to. It'd be very expensive and mass consuming to have a bunch of CO2 scrubbing going on. Ideally on a Mars base, you'd have like a lush ecosystem to manage that, which is a tall order. And I'd be willing to guess you could bring the baby to term, maybe, although, you take that suite of stuff I just described and throw it at a fetus. Who knows? It's obviously never come up on Earth, but who knows? Probably, maybe, who knows? But the real question, often when this comes up, it's like, well, can you have sex? Can you have babies? But in order to have a settlement, that babies have to develop through all the stages of human development to be adults who can have children. And that's where it gets really scary. So you describe all these medical things. Imagine applying them to a kid whose bones are developing, right? Whose vascular system is developing, brain is developing. We really have no idea. And so the scary thing is not that we can't get this data, it's that without this data, if we have Elon Musk is saying we'll be there in 30 years, no one is collecting this data. There's really haphazard experiments over time. There's not much agency funding. As far as I can tell, there's no funding from crazy billionaires. We need this data. It's going to be very painstaking to get, arguably unethical to get, because you at least have to experiment on like primates before you're willing to do it on human women. And it's hard to imagine how you could even get good data unethically in a matter of decades. Like, it should be a problem we're pursuing now if we're really serious about space.
Right.
Like, if tomorrow we found out Earth was going to be dead in 100 years, this would be part of the crash course, a big part of it. And what also worries is that if you do execute on this settlement and you've got kids being born in these conditions where you would expect a higher than normal rate of abnormality, say kids with cognitive deficits, physical deficits, who have trouble contributing to this hostile environment where they can't get any care. On Earth, when you have special needs children, some of us would complain about government services not being quite adequate, but there are at least services. There are ways to take care of these human beings. And that wouldn't be true on any kind of medium-term Mars settlement. And what's scary is we found 3 different quotes from advocates in this community willing to say some version of, well, we'll just have to have natural selection do its thing,
God.
Right? Which you're like, holy crap, this is like a horror science fiction novel.
That really, really is horrifying.
They're just saying the quiet part out loud, though. This is what would happen if tomorrow you snapped your fingers and there were 1 million people on Mars. You would be doing a mass experiment on babies, the result of which would probably be a large number of children who couldn't be cared for. So, I when we say we're concerned about space ethics, people are imagining we're going to be like, do you really want capitalism on the moon? And there are people who want to bark up that tree, but we're like, what we don't want is vast experiments on babies for no reason, which seems to be a reasonable ethical posture for anyone, anywhere, ever.
And then child development is basically just all the stuff we already talked about. Which seems hard enough on an adult human, and then child development seems hard and complicated. One unsettling fact from your book is that there was a startup called Space Life Origin that was announced in 2018, and their goal was to have the first human birth in space by 2024. So this year we could have had a human birth. But in 2019, their CEO left citing serious ethical, safety, and medical concerns. So yeah, it seems like this does just seem ethically incredibly fraught, and we have to do years and years, because child development takes time. You can't rush it. Of experimentation somehow ethically.
People have this idea that space stations are kind of organized scientific projects that are kind of going down the line on big questions, and they're not. Space stations are built for politics, and then cool scientists jam stuff onto them. So the result of that is if you're someone like us who's had to do research, you say, well, have we solved like space psychology? There's not going to be a textbook that goes through like the 50-year experiment that we've been honing in on issues. What you have is 50 years of grab bag stuff. And it's the same in reproduction. So you have like quail eggs have gone to space, and like some rat systems have gone to space. Various plants have gone to space. Geckos, certain types of fish have gone to space, right? But there's not what you would want. What you would want is something like a module devoted to rats having generations in space. And that would be a start, right? It still wouldn't say human people, humans can do this, right? But that would be what you would want to sort of start answering these questions to see if you get problems over time. And I will say, some experiments seem to go just fine. Some don't. So we see in some cases like cellular deformation. One case had like stillbirth. I think that was with rats. I want to say when they got home though. And some have like head deformation and stuff like this. And, what's worrisome about that is we don't know the culprit, right? There are many altered conditions in space. So you can keep a control group back home. That's great. But we don't so to give you one example, we observe in males lower testosterone and in females lower oxytocin, very scary for reproduction. And maybe it's just stress. So there was, I think we talked about this in the book, there were early experiments suggested, I think it was female rats stop cycling when they go up. And it turns out that's not true. You just have to wait longer.
Oh, wow.
So probably what happens is you've just put them through enormous stress. And at least with a human, you're like, by the way, we're going to space now. A rat is just like, what the hell is going on? So, but it's like, not only are there scary things happening, but we don't know the precise cause. So that's why I say these experiments would take at least decades, because you'd have to start from simpler systems and you'd have to slowly, ideally work your way up to something like a moon base with human beings in it, somehow ethically.
Okay, so the next challenge is creating self-sustaining habitats wherever we do go. Yeah, how hard is that?
Super hard, but super awesome. So I'm like an avid gardener. So this question of closed loop ecology is just brings me joy to talk about. So let's spend a lot more money on it just because Zach thinks it's cool.
Because it sounds fun. Yep.
Yeah. So, okay. So, if you're on Mars, say, you would much rather grow food on site, right? Probably in the form of plants. We could talk about animals later if you want, but likely plants. And plants are good for a variety of reasons, right? So they help you, ameliorate Mars soil. Mars soil is like dead, awful stuff. But, if you have organic matter and you're careful about the chemicals, you could in principle turn it into real soil you could use. Also, plants generate oxygen. They can be part of like bacterial systems that help cleanse water and turn waste into, healthy, safe stuff. Mm-hmm. And the question is how to do that when on Mars you're going to be in a sealed container, most likely, almost certainly, right? And so we never do this on Earth. The greenhouse is almost never sealed, with the exception of times we tried to do it to learn about how to do it in space. And the problem is we haven't done this very much, and we've never really done it at scale. You could name it on a short document. You could bullet point every time it's been tried. So the first couple attempts were by the Soviets. There's a set of systems called BIOS 1, BIOS 2, BIOS 3. And they're kind of funny. BIOS 1 is, you imagine just like an apartment or something. But there's like a huge algae vat running chlorella that is good at generating oxygen. And so they tried this. One problem with chlorella is, in theory, you can get like a lot of fat and protein from it. Apparently it just tastes bad, or is kind of sad to only eat algae, like it's a bad sci-fi novel. Yep. But also just they didn't fully close the system. I think they brought in like meat, and I don't think they had all the oxygen. I have to look at my notes, but it wasn't fully closed. It was kind of small. Still kind of cool. They did BIOS 2 and BIOS 3. They kind of expanded the system, added more variety of plants. Never fully closed though. They again, like the phrase we found was, quote, Siberians have to have their meat. So typically you don't necessarily want meat because meat is a very inefficient source of calories.
Yep.
Because they're just like, if you imagine you have a bowl of soybeans and you could either eat it or feed to a cow, yep. Obviously the better call is the soybeans. The best experiment we've done to date is Biosphere 2. If you're wondering what Biosphere 1 is, Biosphere 1 refers to Earth. Biosphere 2 is kind of a cute name. So this was a facility kind of made by crazy people in Arizona in the early 90s. It was a sealed greenhouse. And sealed, they claim, as tightly as like the space shuttle, which might surprise you is not perfectly sealed, but good enough. And but a really tight seal. And it was a 3.14 acre campus, just absolutely enormous. For people who don't have an offhand sense, like I'll say a football pitch is 1 acre. Yes. But huge, right? And 8 people went in, and 8 people came out 2 years later. So it's often remembered as a failure, but it did kind of work.
That's pretty awesome.
I think so. I think it's awesome. I mean, it's easy to make fun of. They screwed up a lot of stupid stuff. Like at one point they had to pipe in oxygen. There's this story, and I've repeated this myself, which is the concrete was pulling out oxygen. I was just talking to a guy about this, and it actually pulled out CO2, but that's kind of the same problem because the oxygen is bound up in the CO2. And so when that happens, slowly oxygen is leaving the system. And so at one point they're getting like, not quite suffocating, but getting listless, and like it's hard to climb the stairs, right? And so they had to pipe in oxygen, which is actually a big controversy. Like, do we do this? Do we like wuss out and breathe, you know?
Right.
Okay, so that's a problem. Food was a problem. They lost a lot of body weight. I think for women it was like 10%, men it was like 18%, and they weren't like chubby to begin with. And a big thing, actually, this seems small, but when you start to think about a realistic space, they spent, the numbers are in the book, but something like most of their time, 6 days a week, were just survival, right? We're just growing enough food and processing it to live any like subsistence. I always, it's funny, I always think like I have a great grandfather who was a farmer, and probably if you told him, they spent most of their time on the farm, it'd be like, yes, obviously.
Be like, yep.
but
yeah, but now I'm like, they what?
They what? Right. Which you should think about every time someone's like, oh, well, and they'll run the nuclear reactor, and they'll cleanse all the soil, and they'll XYZ, but again, it did basically work, and there's a lot of stupid stuff they could have corrected for the second run, so they went 2 years. Like there's a lot of the trees weren't even fruiting yet. If you've grown fruit trees, they can take like 3 to 5 years to bear fruit. They had some animals that were just basically stupid calls. They got like the wrong species of chickens and pigs and things. But so, you can imagine a world where it kept going, it was well run, and we had like 30 years of running this. We know a lot, right? So we don't. It's like with babies, where what we really want is like longitudinal data over a great amount of time. Because maybe, there was a concern at the beginning that this sealed ecosystem would just turn into like green goo, and it didn't. But there were problems, like they had mildew. They lost all of their beans, which, as you might imagine, are one of the best sources of protein. And so they had to eat like fodder beans meant for goats, and it was bad, and this is stuff like probably could be fixed, but maybe not, maybe you really, or maybe not without a lot of knowledge about how to manage ecosystems. So since then, that is easily the biggest, most elaborate experiment like this we have ever done. You're talking for 1 million people, like Elon Musk is saying, you need a greenhouse the size of double Singapore. Right? So we do not have a science for this. The last textbook is from like 2003. What you really want is to run this experiment many ways, many times. So to give you a trivial thing, Biosphere 2 only had a ½ acre for intensive agriculture. By the end, they were colonizing the other biomes with more ag stuff.
Wow.
And so probably what you really want, if you're not run by sort of slightly crazy, artsy, 90s people, is to just start with intensive ag with an eye toward oxygen production. But again, we don't know. You want some sort of massive software system that can think about this really intricate ecosystem design. We don't have it. And the last thing to say on that is, like with babies, you can't just get the data. Right? You can't even throw money at it. You should, but you're not going to go fast because it's an ecosystem. You're moving at the speed of saplings, right? It's going to take decades. Nobody is throwing the right amount of money, right? We have little tiny systems. Again, if Jeff Bezos or whoever wants us on the moon or Mars in 30 years, we need the answer to this, unless you want a massive armada bringing food all the time at enormous cost.
Louis Dartnell on changes we could make today to make us more resilient to potential catastrophes.
Yeah, I was interested in talking a bit about practical adjustments we could make now, basically, to make society more resilient in the future. So we can imagine a scenario where humanity faces some severe shock, but it's on the borderline between a situation where we experience a series of cascading failures versus get our act together while we still have access to pre-disaster technology and rebuild in a kind of orderly fashion. In that kind of case, what are some ways that we can organize things now that might make a difference between those two futures?
Yeah, so I think the idea here is that, can you engineer the situation so that you fail gracefully? That if you have just experienced a catastrophic shock, rather than the whole system snapping and fracturing completely, can you cushion the fall slightly or catch your fall so you don't regress too far before pulling yourself back up? And without wanting to bat away the question, because I do think it's a good one, I wouldn't know how to go about answering it, because again, I think it's so dependent on what was the event in the first place, what is the scenario we find ourselves in, how many people have died, how many, what were nation states are now at war with each other over the resources that they are looking for their own population. I mean, other than things we've already talked about, such as saving not just libraries of useful information that tell people how to go back to a slightly simpler state and slightly lower technological level and pull them back up, but repositories of the most useful tools as well. Mm-hmm. Things that, again, to link back to appropriate technology, things that you could repair perhaps at the village level rather than having to send back to a factory in China to get it repaired and start breaking some of those ties of the global transport of things around the world and make it a bit more local. And I mean, again, to link this to sort of current affairs, the EU as a whole and the world and in general as well are starting to address, where do we get our oil from? Do we continue getting it from Russia? Because this is now very problematic. Do we try to sever our connection with oil, at least Russian oil, and try to find it elsewhere? Or, and you can probably guess what my point of view is, do we take this opportunity to fundamentally change the question and look how we can not use oil at all? Can we go much more towards renewables, to hydropower, to wind, to solar? Can we break our reliance on something that we get from another nation state, which they then basically use as political leverage? And so a lot of these topics in current affairs do link very, very directly to people looking at catastrophe studies and rebooting. They're different aspects of the same coin.
I think there's some stuff that we do today, which is like, slightly cheaper for us now, but looks catastrophic from a resilience point of view. I suppose, one example is it seems like we're making more and more things like, tractors, cars, like internet connected in such a way where these items begin to break down and stop functioning if you don't have access to a computer to debug them, or they can't get regular patches from the internet, or they start complaining and then break down. And people after the apocalypse might not be able to get their cars working, just so that we could slightly do some better patent control for Tesla's vehicles by having their software updates all the time. That's one where I wonder, legally, maybe we should just say, look, unfortunately, all of these essential equipment, it has to be able to operate even if it never connects to the internet again, because there's a possibility that the internet will disappear and we still need to have tractors.
Well, I think that's a great point, Rob, and it links quite closely to the sort of right to repair. So there's been a change in the legislation in the UK, and that absolutely is a great idea, because it breaks the bond slightly between the manufacturer and the person that sold something to you, that you should be able to take it to anyone to repair, if not have a go at repairing it yourself. And there's a whole bunch of wonderful sort of repair cafes and organizations have set up to show people how to fix things when they break, to reestablish that connection between ourselves and our technology. So you're right, Rob. There are low-hanging fruits. There are little things we can start changing.
Yeah, maybe another. So how big an issue do you think it would be that, so most farms are currently sowing seeds where you can't then harvest the seeds of those crops and then sow them again, because they just become rapidly sterile because, for reasons I guess we won't go into. But it makes me wonder, after the apocalypse, once these fantastic factories that are producing these very high yielding but sterile seeds disappear, will we have enough seeds to sow the next crop that we're gonna need? And will people be able to find the seeds that they need in order to resume agriculture?
Yes, I don't think the solution is to stop using these hybrid crops, because the reason we use them is they are so fabulously high yielding, and we need that nowadays to feed the world population that we have. So I don't think the solution is to change how we are currently doing things. I think the solution is more, let's just be sensible about this and keep a repository of a simple alternative to go back to have like a save file on our computer in case we ever have to go back to it. And that would be as basic as, sort of ancient Egyptian technology of having some granaries, some warehouses stocked with heirloom crop seeds, not these hybrid crop seeds, that you can crack open and go back to if you need to, if you start needing to have sort of, regenerative farming where you can keep back seed corn and plant it next year rather than going back to the hybrids each time. Because you're right, you really don't want to start losing crops, because each of those represents technology which has taken thousands of years to develop of selective breeding.
Christian Ruhl on thoughtful philanthropy to reduce the impact of nuclear catastrophes.
So actually, like, Founders Pledge are putting our money where our mouths are, and we recently kind of made a grant, a 3-year grant, $2.4 million, which, by the way, that puts us as like major funder in the field now, which is crazy, right? That shouldn't be the case.
Wild.
But this project called Averting Armageddon at Carnegie, led by James Acton and Ankit Panda. Basically, it asks a lot of these questions about war limitation, escalation management over 3 years. Think about, like, really in-depth, what can we do here? And they're asking, hey, what limits can we actually come up with? Which ones might stick? What are the technical obstacles? Things like hotlines failing, and sort of what can we do to make sure that these things go better?
Yeah, that does sound like a great grant to make. And just to reiterate that it is wild that you are now a major funder in the nuclear space with only $2.4 million.
Right.
So I guess that brings us to, this weird fact that very few institutions work on these kind of right of boom interventions.
Yeah, that's right. So in nuclear issues, we've heard this anecdotally, that sort of right of boom interventions are only a small fraction of the total amount of work. We looked into this a little bit, tried to quantify it, and it looks like it's about like 3.3% or so of philanthropic funding, at least over the last 10 years or so. Again, it's kind of challenging to actually come up with an estimate because, like, the right of boom, left of boom distinction is a little bit fuzzy. But we searched through the funding database, really tried to find any grant that could plausibly be considered right of boom, came up with this rough 1 in 30 number, and then ran that by a bunch of nuclear experts, and they agreed, said, yep, literally nobody works on this. Most of them thought that estimate was probably too high.
That's wild. Yeah, that's truly, truly wild. I guess I can imagine a few reasons for this, but before I make guesses, what do you think the most common ones are?
Yeah, great question. So I point you to a report called Philanthropy to the Right of Boom. It's also in the nuclear report. So, like, why do we care that something is neglected? Many reasons, but 2 of them is that there might be low-hanging fruit to be found. Policy advocacy might be easier when a space is less crowded. But importantly, like, neglectedness could also be an indicator that something is actually a bad idea. There's a reason people aren't doing it, right? So we need to look into the reasons that something is neglected. I think there are a couple of bad reasons. So this way of thinking has historically been associated with kind of hawkish Cold War thinking. And it kind of still carries that ideological stain. So it's like a political, PR, ideological problem. We interviewed a lot of experts about this and kind of asked, and one thing that surprised me was sort of the answer was always like, oh, it just kind of has like bad vibes. Since the Cold War, we don't do this.
Wow.
And that's what it comes down to.
Huh. I guess somehow I actually do. I feel like I get it. Like, I don't believe it when I inspect it, but when I'm like imagining the US government investing in something like, I don't know, systems to make sure they can communicate with another country in the event of nuclear war, I'm like, how dare they plan for a nuclear war to happen? It just feels kind of outrageous. It feels to me like upsetting and yucky, just really unpalatable that anyone's even thinking about this. So I do kind of get it. But yeah, I would hope that the people thinking seriously about what to invest their resources in would like inspect that a bit closer.
It does feel yucky, and like I personally feel that a lot when working on these issues. It feels abhorrent to think about sort of using nuclear weapons, but at the same time, like when we think about it rationally, this is something that we do need to think about. But good reasons that people might say, let's not pursue these kinds of interventions. One is that for various reasons, sort of decreasing the consequences of a nuclear war, you might think maybe that actually makes nuclear war more likely. So it makes it seem winnable, it makes it seem less abhorrent, sort of maybe undermines deterrence in one way or another. I lump this all into one kind of categories where sort of decreasing consequences increases probabilities. So I kind of, to respond to that, I guess we can go back to the car analogy again, right? Like, let's imagine we're in this town where for some reason they haven't had cars and cars are new. And it's been a few weeks and we haven't had any car crashes. And so we've come up with like traffic lights, rules of the road, driver's licenses, so on. But we don't have seatbelts, we don't have airbags, we don't have ambulances. And like, you know, maybe we want to suggest like, hey, we should think about these like bags that could inflate and somehow prevent the crash from being as bad. I don't really know what it looks like. Maybe we should like spend some money into a research project to see what it looked like. And then people might say, you know, oh, actually, what makes people safe drivers is that they're worried about crashing their cars. And then a couple of responses to that is like, maybe, but they're also like drunk drivers. And we know from history that sort of nuclear decision makers sometimes get drunk. There are malfunctions, there are accidents, all kinds of things can go wrong. So like if we're thinking about mitigating nuclear winter and we're worried about like, oh, might this make nuclear war more probable? My simple answer to that is that decision makers generally don't even think about nuclear winter in the first place. And that means that if we're able to sort of decrease the probability of nuclear winter, that might not even enter into the decision-making calculus. And like if you look at like the like historical examples of how decisions get made, what do they think about? They're not like, oh, you know, will 2 billion people die or will 1 billion people die? They say, one, this is horrifying, many people could die. And we know that humans are scope insensitive from sort of various experiments. And they think about things like, oh, the upcoming like election, I wonder if I look weak if I don't do this, right? The sort of like rational calculation doesn't happen. And, you know, if you think about like who might die from a nuclear winter, I think like horrifyingly sort of already the like marginalized people, sort of people in the global south living in extreme poverty. And so do we think that enters the decision-making calculus of leaders in rich countries? Actually, here's the thing. We do have some evidence, right?
That's really dark.
Yeah, we have some evidence about sort of the behavior of leaders in sort of like the political elite in rich countries. And it's generally that like they don't do anything about this sort of like global poor, starving and dying. Miserable deaths happens every single day. And except for sort of small handful of people, we let this tragedy happen right under our eyes. So the idea that that would change during nuclear war just doesn't make sense to me.
That's just like not a key consideration for them. And on the one hand, that is incredibly sad and dark and depressing. Mm-hmm. And on the other hand, it means that this kind of risk is actually less worrying. Yeah, I think I basically at least buy that for some of these. I can imagine the argument being a little stronger for others. And so maybe there's like an interesting angle, which is like we prioritize especially highly interventions that seem especially unlikely to enter into the calculus of these decision makers.
And like what's happening here is we're making like empirical claims about the psychology of decision making, often without sort of empirical evidence. And, you know, I'll like make an offer here. I'd be willing to take a bet with anybody if we ran sort of an experimental war game about this. Decision makers would be sort of fairly insensitive to the numbers. You know, if somebody's worried about 200 million Americans dying, or 100 million Americans dying, I think in the brain of sort of most humans, that's just like the end of everything that I care about. And it's horrifying and sort of hard to even think about those numbers.
Toby Ord on whether civilization could rebuild from a small surviving population.
Imagining the world where there's a massive nuclear war and kind of most of the surviving people are in New Zealand or Chile or Argentina or whatever. I guess it seems like most people think that it's very likely that those people would then be able to rebuild all the civilization that we have now and then potentially eventually more later on. That basically there's a very good chance it would recover. Are there any reasons for thinking that we just might not recover? I know sometimes people mention, for example, that we would have used up all the fossil fuels, so that would be harder for them to build up again.
So I think that this is a very uncertain issue. And I think you'll find that people have very different views on this probability of recovery. Some people think that it's 99.9% chance we'll recover. Yeah. And really some people think that it's like a 90% chance we won't recover. And it's very, very wide disagreement about a topic that we have very little actual information on. So I've tried to be fairly cautious about that since I'm not an expert on it, to treat it as a live possibility, but something that I'm not putting all my weight on. So when people talk about civilization collapse, it's a fascinating area, I think, for conversation and people in existential risk A lot of the literature on it is just about individual civilizations, such as a particular dynasty of the Egyptian civilization collapsing, where they treat, say, Egypt as several civilizations, as opposed to treating, say, Western Europe as a civilization or something like that. It's very fine-grained, typically. But what we're talking about is, at the very least, a global collapse of civilization. And then sometimes that is thought about as things like moving to a pre-industrial time. But I'm talking about it in the book, that the level that I think is most salient that I'm using is that there is no civilization. So it's in the same way that 15,000 years ago, there was no civilization. And what would be needed to get such a severe level of collapse? It could be that I'm analyzing it at the wrong level, and that the dangers are more from having smaller levels of collapse is, sufficiently more likely that even though we're more likely to recover, there's still the kind of greater chance of screwing things up. It's very unclear, but for my purposes, I'm thinking of it as there's no civilization anymore. And it's very hard to see how nuclear war could get you to that level. Also, there's the kind of reassuring aspect that civilization has independently developed more than 5 times in different parts of the world from pre-civilized world. So that's something where, therefore, it's very hard to think that there's only a 10% chance civilization would come back or something, since why did it come so many times so far?
Interestingly, we've only had one industrial revolution, though. So what if we go back to 1500? And I guess some people think that the industrial revolution was very contingent on particular aspects of technology and politics. No, not everyone, but yeah.
Yeah, so that's a different approach. I think at Openphil, their writings on this, they've been more concerned about that level. So what would be needed to knock things back to a pre-industrial world, and then the chance of kind of getting industry back as I think that's interesting, and there should be more discussion of what's the relevant level that does most of the work. And that one, people who think that the values that came out of this change as well, that were something that's very fragile, and if you got industrial civilization back, they'd have different values. That's another kind of potential argument. It's not one that I draw upon, but that some people make. The way I think about this is that it's not that the collapsed civilization would then go on forever, to the end of time, as an alternative to extinction. It's rather that it would be more likely to end its state of non-civilized world by moving to extinction than by moving upwards to a civilized world, or some kind of fulfilling of humanity's potential, such that the event that knocked out civilization would be the key event in human history. That's the property that I think is needed in order to make that the existential catastrophe.
You had this really nice point in the book about how people talk about civilizational collapse in the past. So the Roman Empire collapsed in some sense, became more politically fragmented and disorganized. But that doesn't mean that many of the people there died, or that the cities ceased to exist. And even the eastern part of it kind of continued on a pace, and it didn't affect China or the Americas. So it's actually quite a localized political breakdown.
That's right. And so from my view, I fail to see why almost any of these numbers on civilizational lifetimes and things like that are relevant at all. I think that there is some case someone could make that they're relevant. For example, they could say that we're so interconnected now that the level of interconnectedness of the world is similar to the interconnectedness of one of these previous civilizations. I don't think it's quite true, but if they could make that case, then maybe that would kind of suggest why it's the relevant unit of inquiry. But a useful example, I think, is this case with the Black Death that killed something like a third of the people in Europe. And it didn't cause any kind of regional collapse of civilization. Things just kind of moved through. And so it seems like this is a kind of case where, we do seem to be quite robust.
Luisa Rodriguez on how fast populations might rebound.
Taking now the assumption that we would recover, how fast could we expect population to rebound if things go well?
If you think the population would grow at the fastest level that it ever has, which is in the 1960s, that was about 2.2% per year, then you'd get about a tenfold increase in population every 100 years. So if you lost 90% of the population, you'd be back to current levels within 100 years. And then if you think that population is going to grow slower, so maybe the level it did when humans were just agriculturalists, then you could recover a population from 90% population loss to current levels in about 240 years, which is still really, really fast.
Yeah, it's kind of shockingly fast, or it seems like it should take ages. But I suppose it's just the magic of exponential growth means that it doesn't take quite as long as you think. If people can keep having kids at a decent clip.
Exactly. Yeah. So even the most kind of pessimistic scenarios I think we thought of were if 99.999% of people died which is a huge number of people dying, then at kind of that 1%, so agriculturalist level of population growth, you'd still expect the population to reach current levels in about 1,200 years.
Okay.
So
I suppose we could compound all these scenarios into an even more pessimistic one where you have 99.9% gone and you're only growing at the hunter-gatherer level, which was 0.1%. Would get back to the original population in 7,000 years.
Wow.
I guess maintaining a 0.1% population growth rate the entire time just seems
really
very
implausible.
strange. Yeah, because it's so, well, it seems like it should either be below zero or more above zero than that. That's just like knife edge level.
That's like, it would be really surprising if at 6 billion, we were still
going.
at like hunter-gatherer levels of growth rates.
David Denkenberger on the odd civilization recovers even without much preparation.
So given that it seems like even in an all-out nuclear war where we didn't have very good food alternatives, there's a good chance that, 10, 20, 30% of people would survive, maybe even more than that. Why wouldn't we recover?
I personally am fairly optimistic that we would recover. There's been some talk about why we might not recover. For instance, we don't have the easily accessible fossil fuels anymore. I think there are still routes of recovering it, but it would be more challenging. Another one is potentially something that wiped out the grass family, because so many civilizations have been built on the grass family, corn or wheat. Now the exception is potatoes, like in South America. Then you could say, well, maybe the trauma of the catastrophe would select for people who are nastier or not trusting. So maybe we wouldn't develop that trust of people who are not related to us. I don't know how high probability that is, but it's, I think, at least possible. Maybe the disaster somehow permanently affects our IQ or some other characteristic that made development of civilization not possible. I think Eliezer Yudkowsky said something like, we are the least intelligent that it is possible to develop industrial civilization, as in we just were able to cross the threshold. Because it's interesting that it took us something like 100,000 years from anatomically modern humans to develop from where we are now. If we had just had the knowledge we have now, we could have grown at 3% population growth per year, and it would only take a few centuries. But it took us 100,000 years. So, like I say, I'm optimistic that we would recover, but it's just, I think, not a
sure thing.
Yeah.
Athena Aktipis on the best ways to prepare for a catastrophe and keeping it fun.
What kind of advice do you have about how people should think about the apocalypse in order to, I guess, be happier while they're doing it and maybe think about it in a more productive way?
Yeah. So I think one of the easiest things that we can do is just think about risk management in a fun way, right? So like there are a lot of things that we can do at the household level to manage risk better. And then we can also sort of build communities that do a better job of managing risk. And then you can take that up to, the highest scales as well. And things like making sure that you're ready for an emergency, right? So there's this idea of all hazards preparation, which is basically just emergency preparation, but you can make it a little bit more fun by being like, hey, are you ready for the zombie apocalypse? Do you have like 72 hours worth of stuff so you could just shelter in place? So things like some basic emergency preparedness, that actually helps to make our overall systems more robust too, because if there is a natural disaster and all households are able to shelter in place, say for 72 hours, then whatever institutional level support is available to deal with the problem can be focused on the acute problem, as opposed to having to split effort between the problem and the humanitarian crisis that can emerge in those situations. And then the other one is, kind of building these networks where we can get help in times of need, ask for help. Those often spontaneously emerge in disasters, but, having some networks already set up ahead of time before things get really bad it's an easy way to manage risk by sort of doing what people call limited risk pooling, where it's if you're in need and I'm available, I have enough to help, then I'll just help you without expecting to get paid back.
That's interesting. I haven't really heard that idea before. What sort of agreements would you, or like what sort of relationships might you want to build ahead of time? I suppose here we're kind of thinking of disasters like, well, I suppose in an extreme case, nuclear war, possibly, if you manage to survive it. I guess also earthquakes would be another classic, or massive wildfires in some places.
Yep, flooding, massive power outages in the winter or the summer, right? Like there are a lot of...
Yeah, I suppose now we have to worry about cyber attacks that could shut down the electricity grid, something kind of unprecedented. Yeah.
Absolutely. Yeah. Yeah. So this kind of then opens up like this whole other area of my work, which is really about looking at cooperation in human society. So we have this project called the Human Generosity Project, where we've looked at almost a dozen small scale societies around the world now, and how they help each other. How people within those societies help each other in times of need. And we have found that if you kind of look at the risk management strategies that people are using, that need-based transfers, this like, hey, if I'm in need, I will only ask for help if I'm genuinely in need. And then if you receive a request, you will help if you're able to without going below what you need. So we see this in pretty much every society. The one society where they don't use it as much as this society I was telling you about in Mongolia, where they have these, winters that are just horrible. So they have to help each other kind of ahead of time. They have to manage the risk proactively rather than,
I see.
Because they can't like go to each other's houses when there's like 6 feet of snow outside.
Oh, wow. Okay. Yeah. So what do they do?
So they will help each other build shelters and make sure that everybody has the resources that they need. Yeah. So it's basically sheltering in place for the winter. They're helping each other be able to do that for their families and their livestock.
Wow.
But anyway,
I would emigrate. This sounds awful.
Yeah. But the bottom line here is that people, around the world in small scale societies do this. And also like in rural societies here in the US. So we've studied ranchers in the Southwest, here in Arizona and New Mexico, near the border with Mexico. And they have a system they call neighboring, which is largely a need-based transfer system where they help each other in times of need. And they don't expect to get paid back for those things that like arise unpredictably. So these are things that already exist, and they're really good at handling the kinds of things that typically we want insurance for, right? Those things that we can't predict and can't control. And if you take it to the extreme, there's certain things that market-based insurance actually cannot insure against because there's no way to
everyone gets hit at once.
Yeah, so that's one possibility. Everyone gets hit at once. But another is just that it hasn't happened yet, and there's no way to really calculate what the probability is of the event or how severe it would be. And in the absence of any of that information, you can't calculate what an insurance premium could be. It's an actuarial problem, right? It's like you need the data in order to price the insurance. But with these need-based transfer networks, they like you can at least have them in place for any kinds of needs that arise unpredictably. Now, whether the system will be able to effectively handle those is another question, but you at least are able to set up systems that can deal with things that have never happened before, that we can't even understand what the risks are like. So,
yeah. So I live in a city, London. What should I try to coordinate with my neighbors around? I suppose a big issue is people don't have very large places, so you can't really it's like difficult to stockpile enough water or food or anything like that. And I guess in a war scenario, London's a very juicy target, so things could get pretty grim.
Yeah, I mean, I think no matter where you live, having 72 hours of supplies is wise, and you can actually do this in a way that makes sense for having a very busy lifestyle, which is something that I love. So, if you
apocalypse prep on the go.
Exactly. And it's like, apocalypse casual lifestyle. Like, how do you do this? Yeah. Well, like, for example, if you like couscous is a great food to have around. Not only can you prepare it very quickly on a weeknight if you need something to eat, but it stores well, and you actually don't even need hot water to prepare it. You can just add water to it and let it sit for like a half an hour, and then you could eat it. So if couscous is something that like you're fine with, then you can just make sure to buy enough couscous at the store that you could, at least have it be part of what you would be eating for those 72 hours. And whenever you buy a new one, you put it at the back and you just have like some extras. And then,
Keep it going, yeah.
Like it also makes it easier when you're super busy and you don't have time to go to the store. You're like, oh, I got my 72 hours of preps. I mean, obviously next time you go to the store, you want to like
you gotta
re-up.
do extra. Yeah.
But, sort of thinking about being prepared, not as like, oh, I have to go and like figure out how to buy like really long shelf life food on Amazon. And then, who's a reliable source for this? No, you just look at the kinds of things that you like to eat that are shelf stable and just have more of those on hand, because that will make your day-to-day life easier and also will put you in a better position if something totally unexpected happens and you have to shelter in place.
Yeah, the UK has a pretty precarious food situation, actually, because it relies on constant stream of imports. It doesn't produce anywhere near enough food for the population that it has. So I would suggest having enough food for weeks, conceivably months, would be not outrageous if you were able to do that here. I guess the storage issues. I did at one point store a whole bunch of rice, but I didn't store it well enough and mice got into it. And that was very embarrassing. I was a very amateurish prepper.
Yeah.
But yes, now we have some rice and pasta in a thick Tupperware.
Excellent,
the mice
excellent.
can't get through.
Yeah. And I mean, I think like that another thing is just not feeling intimidated by like, oh, I have to do all of these things. It's like, no, just start with like having enough water around and, having some extra dry food that is stuff that you eat anyway. And then, you can work from there. It's not like you have to do all of the things all at once or anticipate every possibility because you just can't, and having conversations with people about like, what they're doing, do they have their preps? Like it can be fun. And, I mean, if you get into like a, little social competition about it, it could be like playful fun. Like, all right, let's, I have this idea for like a new kind of dinner party. I haven't tried it yet, but I absolutely want to, which is like you like roll the dice to like figure out whose house you're going to go to. And then you show up at that house and then you have to figure out how to like make a really nice dinner with just the shelf stable prep food that's there. And so then you kind of practice like making fun meals and, surviving in your like mini apocalypse dinner party. So stuff like that, I think, we could make it fun. And then it just kind of puts our attention on like, maybe we should just be ready for the unexpected so that at least we have some more time to plan, and that's the thing. It's like, you might not be able to like have enough food around to actually manage the risk of something catastrophic that would happen. But you can have enough food around so that you have a few days to figure out what your next steps are if something, really catastrophic happens.
Yeah. Makes a lot of sense. Because when you start talking about stockpiling food to protect yourself against disasters, I think some people's eyes kind of roll and think you're a bit crazy. They start associating you with preppers who get really into it. Maybe a little bit too into it. But earlier this year, my partner and I did spend a bunch of time thinking about, what would we do if there's a nuclear war and we survive? Like, what would that look like? I mean, it was very long odds, but maybe it was getting probable enough that it was worth having a conversation about it.
Yeah.
It is really fun on some level.
Exactly. That's the thing.
I mean, maybe not everyone enjoys this, so it's easier for them to kind of have disdain for survivalists. But there is something just, very entertaining. I guess, our lives can be a little bit boring on a day-to-day level. Imagining, what would we do if just everything was destroyed? How would we cope?
Yeah. I mean, there's like people have called it survival porn, right? There's something like just like appealing about like imagining yourself like out there or inside or trying to survive, in challenging odds. It's like a little like it's a story that we like tell ourselves, right? That makes us have fun and feel good.
I saw on your website that you're involved in some like zombie apocalypse medicine preparation thing. I don't really understand the nature of this, but what was it? And I guess what's something useful you learned about surviving the zombie apocalypse specifically?
Yeah. Well, so I started and I'm the executive producer for this like whole group of really fun and interesting scholars. We were called Zombified Media, and we have, the Zombified podcast that I co-host with my friend and colleague, Dave Lundberg-Henrik. We have this live stream channel called Channel Z, where we have all sorts of shows that are, based around the idea that the zombie apocalypse is going on now. And here's how you get your pantry set up. Here's how you, set up your go bag. Here's how you, deal with the zombies outside in a way that makes sense given cooperation theory, right? So we kind of use the zombie apocalypse there as a fun way to engage people. And it all actually started with the zombie apocalypse medicine meeting. So we just had the third one of those. We do those every 2 years. And it's basically an academic conference framed around this idea that the zombie apocalypse is going on, and we have to try to understand, zombie behavior. We have to, look at what are the threats that we're facing in the world now? What are the threats we're facing in the future?
Yeah, what is an unusual? What's an unusual tip that you've learned for how to survive a zombie apocalypse? I mean, I guess there's a wide range of different possible apocalypses of the zombie kind. So maybe you need to be more specific about the exact scenario you find yourself in. But yeah, any advice for listeners?
So absolutely, I've got one big tip, and it applies to all apocalypses, which is to build your Z team. So this is, who are the people who you would want by your side in the zombie apocalypse, or really in any hazard. And that doesn't necessarily mean that somebody, would have to be literally by your side, but somebody who you would want to be sharing information with, that you would want to, be there to back each other up if something went really wrong. And so that's, I think, and that's basically risk transfer. That's the risk pooling, the limited risk pooling. Start setting up those relationships. You probably have a bunch of people in your life already. You just don't even think about them in those terms, but, have a conversation with them about hey, if, the zombie apocalypse happened, what would we do? Or if, a nuclear event happened, if you want to be more serious, right? So you can start to have those conversations and just think about how you can proactively manage your risk. And cultivating that Z team is a super fun way to do it. And, hopefully your Z team members, they're hey, do you have your 72 hours? Because that's it's a
bare minimum to get in the team. Yeah.
And if not, I let me help you. Right. So I think we can approach it from this perspective of how do we kind of bring more people in to this idea of making managing risk fun. And also, we should absolutely not neglect the neighborhoods and communities that we live in, because in the event of an emergency, it's likely that there'll be some interdependence with the people who live near us. And then, we can also think about scaling that up, right? So there's these sister cities programs that really, they arose for cultural exchange and educational exchange. But now, when there are disasters in cities that are sister cities, oftentimes there's just this spontaneous outpouring of help. They're kind of Z team members to each other. So I think we can kind of generalize this Z team idea, this risk transfer idea to a lot of different levels, try to grow those systems that, increase our resilience at the individual level, household level, neighborhood, community, national, international levels. And risk management for the win is how I like to look at it.
Will MacAskill on the virtues of the potato.
Yeah, I guess so. Listeners are dying to know, what is it with you and potatoes?
I just think they're neat.
This might be a little bit of a joke. I think when I say listeners are dying to know, I mean two listeners. But
two listeners. So this did come up at the last Year Global London. During, I think it was May, June 2020, kind of peak of lockdown madness.
Yeah.
I was working hard in the book, and I was often going down kind of rabbit holes that were often very useful. But one I went down was the history of the potato and the potato's long-term impact. And an early draft of the book had a lot of potato-related content. People didn't really like it.
Yeah. It's mostly just a book about potatoes at this point. Yeah.
I do now own many books about potatoes. Yeah. And it stemmed from, so the potato was one of the most important transformative technologies of all time.
Yeah. Tell me more.
When it was first imported to Europe from South America, it was regarded with quite a lot of skepticism because people thought that it would give you leprosy because the skin was looked like the skin of a leper. But it was also just a radically new sort of vegetable. And so it took a while to take off. But then those areas that were suitable for potato-based agriculture and started using it, well, there's one study that suggests that they had radically more urbanization and population growth. So it had basically you could get 3 times as many calories per acre from the potato as you could from
wheat, or
from wheat.
Wow.
Or
it's just so fast growing, or just so efficient at converting sunlight into calories.
Yeah, basically. And it's also quite close to a superfood. So there's this paper, it's by Nathan Nunn and one co-author. It has a section, and it's like got thousands of citations in the Quarterly Journal of Economics.
Yeah.
And it's like section 2, the virtues of the potato. And it's like comparing potatoes to turnips. So potatoes, you can, at least if you're an agricultural worker requiring more calories per day, you can live on nothing but buttery mashed potatoes. So
in reasonable health?
In reasonable health, yeah. So you get all the relevant nutrients, apart from vitamin D and K, which you can get from milk. You also need occasional supplement of like lentils or oats for the molybdenum. But basically, to a first approximation, buttery mashed potatoes can just be your life.
Yeah.
And so, it seemed to be actually just very good nutritionally as well. So it's kind of, the joke I started making was you can draw this analogies between the potato and AI, because it was this like discontinuous technological advancement that in some ways was more general than previous previous vegetables. But it was also recursively self-improving.
Because we kept selecting the best potatoes?
Well, no, because you could, by growing potatoes, it actually was also very good feed for livestock, which produced manure, which allowed you to make many more potatoes.
Okay.
And were you thinking that's a bit of a stretch?
Well, I was thinking, how many cycles of improvement do you get out of that?
You do plateau.
Yeah.
But I think that is also that is relevant, where
that could happen with
exactly
AI,
getting a bit of self-improvement doesn't mean you go forever necessarily.
Yeah, totally.
You can plateau, and it is relevant for thinking about automation kind of more generally, or like productivity improvements more generally, where agriculture in general, we've had these like enormous productivity gains and automation, and actually that's meant that agriculture has become a much smaller part of the economy rather than a bigger one, because like it's the stuff that's like hard to automate but essential that ends up becoming kind of the bottleneck and swells to become the whole economy.
Yeah.
And that could well happen with AI as well. And there's this like economic model on how this might go and how that could be like a bottleneck to kind of singularity-esque growth.
Yeah.
But people thought it was a little flippant.
Right. Didn't make it into the final cut. I think there's almost no mentions of potatoes in the book.
Sadly, it's all gone. But I have been approached for people asking for it for perhaps a standalone article. So maybe it will still see the light of day.
Yeah.
There's a bit. I have commissioned research onto this because the other part of the issue is like the core persistent study. Oh yeah, I did a little bit of. So if you take the persistent study and then just extrapolate it out, then if the potato had never been imported, had never existed, or hadn't been imported to Europe, 1 billion fewer people would be alive today.
Wow. Okay. Wow.
But the question
kind of makes it surprising that the civilizations in the Americas, weren't more powerful or weren't more populous. And if it's so much more efficient at producing calories, you'd think that would be a huge advantage in terms of getting economies of scale and being at the forefront of technological development.
Yeah, I mean that's actually kind of a good argument for some amount of skepticism about the study.
Okay, yeah. Right.
So I have asked Jaime to look into it, because I'm confident the effect size will not be as large as it actually is as is stated in the paper. Well, and I should say the potato stuff, in the last podcast, I made a comment about this persistent study about how potatoes had this enormous long-run impact, and I commented, it probably doesn't check out.
Yeah.
Turns out it checks out. So my interest in potatoes was vindicated all along. It's the most important technology ever invented.
Nice.
Among the most important.
We'll go and issue a correction to that episode.
Okay, please do.
Hey listeners, I hope you enjoyed that compilation. There are many more gems in the full episodes for you to check out if you're craving even more lessons about civilizational collapse and resilience. There's links to all of those in the blog post of this episode. You may also want to read about how you can use your career to work on these issues. On the 80,000 Hours website, we have an article that explains the case for working on reducing existential risks, as well as problem profiles on great power conflict, catastrophic pandemics, nuclear security, extreme climate change, and AI-related catastrophes. Those two are linked in the blog post for this episode. All right, thanks to the production team for putting that compilation together. We'll be back with a fully new interview very soon.